Morning to all of you. We'll be beginning in the next couple of minutes, so please settle down and ensure that your phones are in silent mode. Good morning, everyone. We'll now get started. Welcome to the ACM India annual event. As they say in Odia, I was pleasantly surprised that it's the same as in Kannada. Namaskara, Swagata. A very good morning to all of you. Welcome to the temple city of India, Bhubaneswar. The annual event of ACM India is a flagship event of ACM India, an occasion to celebrate India's computing community coming together. We thank NISA for hosting this annual event and also the co-located events of ARCS and the ACM India W Summit. We warmly welcome all of you to the annual event. We have 4 laureate talks lined up for today and an awards ceremony. Hearty welcome to the speakers and the laureates also. To start the event, it's my pleasure to welcome Professor Hirendranath Ghosh, Director of NISA Bhubaneswar, to inaugurate the event and to briefly address the audience. Professor Nath is a fellow of innumerable academies of sciences and engineering, has contributed to several areas of research, including specific techniques in spectroscopy and materials. He has a long scientific career spanning several departments and institutions of the Department of Atomic Energy. Welcome, Professor Nath.
Good morning. Welcome to Niger. I am very happy to inaugurate this conference in Niger. This is the ACM, basically Association for Computing Machinery. Now, I was thinking yesterday, when all people were taking dinner, the kind of conference we are organizing. Generally, we organize physics, chemistry, mathematics, biology, the main 4 subjects in this institute. But computer science, as it started, I believe strongly that our department needs completely support from people like you. But I welcome all the distinguished speakers and the guests in this organization. Our department in computer science is a very small number of faculty. The new building is coming here, which is within a couple of years it will come. So as I was telling that, it is connected to the mathematics department, and mathematics is the mother of all science. Now the next is computer science. So I guess the computer science subject is such that it's the mother of all engineering and science. So we are very happy to get you here. And I'm sure our faculty and students who are working here or studying in computer science, they will be encouraged. And your encouragement is always necessary for us to grow up at a bigger height. Although it is an education and research institute, but like IISc Bangalore, they have computer science department and they are kind of developed department. Eventually, we are willing to get a very strong department like our physics, chemistry, mathematics, biology. So we need your support. And I am sure you will enjoy the conference and the ambience here and the food in Bhubaneswar. And, if you have time, please visit many temples in this city. So I'm not extending my talk anymore. I'm welcoming all of you. Please enjoy the conference. Thank you.
Thank you very much, Professor. It is now my pleasure to welcome Professor Yanis Ivanitis, Fellow of ACM and IEEE, an exemplar researcher in several specific areas in databases and human-computer interaction, and also the president of ACM. So as the president of ACM, Professor Yanis will provide a report on ACM and its activities.
Thank you. Thank you very much. Before I give you the highlights of ACM, what we are doing and what not, just let me mute this. Okay. How many of you are members of ACM, student members or professional members? Okay, very good. All right. But not all of you. I spotted a few of you up there. So, well, listen carefully, and then by the evening, become members. So, let me give you a bird's eye view of ACM. This annual event of ACM India is a highlight of the year. And now in my second year as president, having had the experience of last year, I was looking forward to coming back and the exchange and the laureates and the students and so on. So it's a great pleasure to be here and to be sharing with you what is happening in ACM. I just want to quickly go over the mission of ACM to emphasize a few things. This was written more than 20 years ago, 25, 30, something like this, and still it is to the point. And I'll be highlighting the key nouns, adjectives, and adverbs in this. So ACM is a global scientific and educational organization dedicated to advancing the art, science, engineering, and application of computing, serving both professional and public interests by fostering the open exchange of information and by promoting the highest professional and ethical standards. I wouldn't change a single comma in this. That's what this ACM is trying to do. The green highlights are the main focus. We do education and science, and we do all aspects of computing. And the red ones is how we do it. And I want to emphasize in the second green line, it's art, science, which is research, but ACM is not just about researchers. It is engineering and application, people that are interdisciplinary with ACM. The director, and thank you for hosting us. It is great campus, great food from yesterday, as you said. It is, thank you. Well, mathematics is the mother of all sciences, you said. I would say was the mother of all sciences. Now computing is the mother of all sciences and engineering. And ACM is not just for research. It is also for engineering. It is also for the applications. And the other thing I want to emphasize is the global part. ACM is not American something or other. It is Association for Computing Machinery. And, you have a Greek being the president, so it cannot be America. So it is global, and the presence in India plays a very important role in it. So let me, no, wrong. So let me give you, most of you are members, but let me give you the aspects of ACM that can, okay, obviously, I'm not doing something right. Or someone else is playing. Okay, so if we go to the region, to the geography dimension, we have regional councils like ACM India, ACM China, ACM Europe, and now we try to see additional structures like this. And okay. Okay. And the other part that you can be a member of and be associated within Mother ACM is either the special interest group that is thematic. We have 38 special interest groups on management of data, on graphics, on operating systems, and so on and so forth. So that's the thematic part. And also the social, and the key thing that we have there is ACMW, which is for women. And we have here with us the chair of ACMW Global, and we also have here the chair of ACMW India. So independent of whether you are a woman or a man, talking to these ladies makes a very big difference, because everyone should be represented according to their representation in the community. And ACM is making a very special effort for this. And so, where is my Mac? Okay. You can belong to any of this, but the nucleus is the chapter. And you can have chapter, and who owns a chapter? It can be, it's mandatory to be kind of geographic, and if it's a student chapter through a university, if it is a professional chapter through, to be local in a country or in a city, if it is a big thing. And optionally, it can be associated with a special interest group. So there are about 700 chapters in ACM. and a third of them are in India. And look at the map. Okay, I mean, it is a small a map of Asia and on all of Asia. Look at the density of the chapters in India, close to 200. And if we zoom in, I mean, you can see even more. So India is doing it right. And it's showing the way to many other parts of the world. And this is, it's not just the size of India, it's not just its importance in the computing industry and academia, but it is the fact that it's doing it right, and this is very important. ACM, besides of the various things that I told you about, the regional councils or the special interest groups or the chapters that you can belong to, has some horizontal bodies that take care of various dimensions of the services that ACM needs to provide. And I won't go to all of them to describe, but I want to focus on the last words in this slide that show the content that is created, what is given to the members and non-members. So for diversity, equity, and inclusion, which is very different from region to region in the world, but everywhere that exists this issue, there are many webinars that support improving the diversity. If you're a practitioner, if you are in industry, or you'll be going to industry, there are many tech talks, again, like webinars and podcasts, like podcasts specifically for practitioners that focus on particular technologies, particular new fields or new ways of doing things, nothing to do with research. And there is a library, is a crown jewel for ACM, publications about many journals in many fields, I mean, always following the trend, tremendous conferences, and many of you are students, and it is often, not in all universities, but the curriculum that is followed for computer science is from the curriculum published by ACM with a EEE and AAAI, and it's just fresh out of the oven, the new one, CS 2023, with many innovations on how to approach computer science and engineering and technology policy influencing policymakers. Because computing now affects every single aspect of our lives. You cannot go even to grocery shopping without computing somehow being involved. And so whatever we do impacts the world. And policymakers need to understand and create policies for this. And of course, policymakers have no clue. It is our responsibility to educate them so that they can come up with the right policy. So, this is roughly what is happening in ACM. Now let me just highlight some initiative that has been going on for from conception about a year plus, and now it is moving into the implementation. It is called ACM 4.0. And it is what we do for the next 25 years, because 2 years ago, ACM was 75 years old, so it's the quarter century of its life. That's why it is 4.0. And this initiative, ACM 4.0, it has 10 presidential task forces. The president, right now it's me, it is focusing on create on 10 different dimensions where ACM needs to change. And ACM, through its products and services, it's trying to serve its members, but also trying to serve society. Remember, professional and public interests in the mission. And so very quickly, I'll go through these task forces. 3 of them have to do about members, a membership model. How do you become a member? What does it mean to be a member? Globalization, to increase the footprint of ACM around the world. And be distributed according to the presence of computing professionals around the world. And youthification, we want you. We want the new brains, the new way of thinking, serve you, and also we want your ideas on how to serve you or how to improve for the good of computing society. For society at large, we have how do you, how many of you are familiar with the United Nations Sustainable Development Goals? Okay, very few. In 2015, the United Nations came up with 17 goals of the development of the world. And they said, as the world develops, the goals should all be sustainable. We cannot continue doing things the way we have been doing. And there are 17 very big goals, none of which can be solved without computing. So if ACM, what are the ways that ACM can help so that computing professionals get involved in voluntary work or in an actual work, funded work, but catalyzed by ACM? The Code of Ethics, which is, again, another crown jewel of ACM, but how do you actionalize it? How do you do open science, which is slowly becoming the way of doing science in the next 5, 10 years? I think all of scientists in all fields will be working openly. The overall product portfolio, and 3 things on the inner workings of ACM: financial model, legal office, and bylaws. I won't go into the details of all of them. The special interest groups work and the journals and everything, other activities focused on technology. I just want to say 2 words on the 3 presidential task forces that have to do with values. They are not technological. They need support from technology, but that's what it is. This is a picture that has been haunting me from the minute I saw it, and it shows the challenges, the societal challenges that we have to face, some of them. And down here, it is some parent telling their child, wash your hands and everything will be fine. And then COVID hit and everything was not fine. But COVID, as much of a problem it has been, a disaster, it is dwarfed by the economic recession that came before COVID and especially during COVID. Many more people died of poverty than of COVID. Okay, so we have to be careful of that. And then recession is dwarfed by climate change, which is dwarfed by biodiversity collapse. And the original picture stopped there, but 2 years ago we had war, and this is dwarfed by war. So what do we do as society, and what can computing professionals do to help alleviate, mitigate, adapt to all this? And ACM can have a big role to play there. So trying to work with the United Nations so that we can establish the right instruments for computing professionals. And this is, of the 17 goals, 4 are in biosphere, 8 is in society, like no more poverty, and equal education for both genders and for all genders and so on, and economy, and then 1 meta goal. So this is one of the task forces, the presidential task forces that will be trying to establish to help. The other one is professional ethical standards. ACM has many policies on how to proceed in professionals, computing professionals, to conduct their life. Remember the last line of the mission, having the highest professional and ethical standards. Well, we have a code of ethics. Many societies around the world have adopted it as is, but how do you actionalize it? How someone in industry working, on the one hand, they have what the boss says to do, and on the other hand, you have the code of ethics. How do you reconcile these two if there is a conflict? So that's that presidential task force. And finally, open science, which means that you don't do your work hidden, then you publish a paper, and then you forget about the paper, you lose the data, nobody knows how you did it. It's not repeatable, it's not reproducible, it's not reusable. Openness says everything in the open. Even one reviewing of a paper, the review is open and you sign the review. It's in the extreme form of openness. And even UNESCO said, this is the way, so United Nations again cares about open science because it helps collaboration among people, reproducibility, transparency to society, and then trust. Yes, what you did, it's here, I can try it, and therefore I have a means to say, yeah, I trust what you told me. And speaking of trust, this is a picture that I like to show. I haven't found any other picture that really captures the concept of trust as vividly as this one. And if you notice, the lower guy, his body is like an A, the way he's extended, and the way she curves her body in the middle, it's like a C, And then if you really extend your imagination for the third guy, you get an M. So ACM means trust. So I definitely declare, not just as president, but just as even as a simple member, I am ACM, and I'm inviting you, you be too. Thank you.
Yeah, thank you very much, President of ACM. As a small token of appreciation on behalf of ACM India, we've planted a tree in your name, and this is the certificate for your tree. I now invite Professor Venkatesh Raman from the Institute of Mathematical Sciences, advisor for many generations of research scholars in the areas of data structure and parameterized complexity, currently serving as the president of ACM India.
So, very good morning. It's again a pleasure to welcome you all to this ACM India's flagship annual event. As Meenakshi said, we have a great lineup of talks and award ceremony. So, Yanis already asked how many of you are ACM members. I don't want to ask how many of you are ACM India members, because there is no such thing as ACM India members. You are an ACM. Seen our website to look at the events. Okay, not too many. Okay, so what I'm going to do in my 5-10 minutes is to give you an overview of ACM India, how it's all started and what are its activities. So, Yanis mentioned about the mission of ACM and the fact that he will not change even a comma or a word in that mission. It's surprising to know that, what he didn't mention is the ACM was started in 1947 when India got independence. And you don't think even computer science is that old, 75 years old. And now you can imagine the visionary of who founded this ACM and their vision that, that long ago they had this great vision. ACM India was started in 2010 to focus on India-specific activities and to continue to advance ACM's mission in India. It's managed by an elected council of 15 members. It's a completely voluntary activity. So these are people who are extremely busy people who are spending the time and effort to give something back to the community. We have a variety of activities for all constituents of its membership. I will just change that, not membership, all constituents of the society, because for many of our activities, to participate in them, you don't really have to be an ACM member. That doesn't give you an excuse not to become an ACM member. So what I'm going to do is to just give you a laundry list of various activities. You will hear a lot of abbreviations. They may not mean anything, and I may not have the time to explain all of it, but I just want to give you a flavor of things, maybe explain one or two things. But more important, you can check them all in the ACM India website. That's there, okay. Okay, and as I said, we have a variety of activities starting, whether you are a school student, college student, researcher, or a practitioner. So for example, there is a team committee working to develop curriculum for school students, because computing for a long time, at least at school, is thought of as, programming or Word or PowerPoint or Excel. And we all know as computer scientists that computing is all about, math and logic and puzzles and a whole lot of things. So we have worked out a curriculum for school students, and it's been implemented in about hundreds of schools in the country. And we actually have an annual conference for the school teachers implementing this conference. It's called Computational Thinking in Schools. And recently, we have also been a nodal point to conduct what is called this Bebrus Challenge, which is an international Olympiad-like competition, but at the school level, a lot more relaxed. It's a more of an aptitude test. And it is just to inculcate computational thinking in schools. So last year's Bebrus Challenge had several lakhs of school students participating from the country. For undergraduate and master's students, we have our summer and winter schools, one of our flagship event. It's a 2-week school on advanced topics. Recently, we've had a number of schools devoted to data science, cybersecurity, IoT and cloud and algorithms and so on and so forth. So this takes you from your college curriculum in a 2 weeks in a residential area, given guest house and a hostel accommodation, and over a period of 2 weeks, you get exposed to top class researchers in the country and to advanced topics. We've recently started research opportunities in computer science. It's like a 1-day workshop. We have an eminent speaker program, just like ACM has a distinguished speaker program. So here is a list of speakers in the website. The chapters can invite them to give a talk, and ACM takes care of all their expenses. In fact, as I heard, there is a current ESP call for speakers is open now, and we're particularly looking for some diverse set of professionals to participate in this ESP program. And of course, we also have a very active ACM India Women chapter, or women, and they conduct a lot of these programs. So many of these programs also cater to a whole range of students. So again, I'm listing these things. As I said, please go check out the website. If you are a student or a professional, you may want to participate in these activities, or if you are an institute and you may want to organize these activities in your institution. So these, please check them out and get back to us during the breaks if you have any questions or comments on them. For PhD students, a lot of activities, and I know the last 2 days we had these ARCs devoted to PhD students, and PK yesterday gave a whole list of things what we do. So here is a list of things. We have what is called a PhD clinic. It's like, it's named after a medical term, doctor. So if you are a PhD student, you're suffering from something, you can write to PhD clinic to solve your problem. You will be connected with some mentor, the doctor mentor who will help you with that. We give partial travel grants to people who have papers in international conferences. Recently, we started what is called a research facilitation grant, through which we also give travel grant to not necessarily to conferences where you have paper, but even invite only conferences where you want to attend. Something like dark stool type conferences for those who are in the know about it. We have a doctoral dissertation award and whole lot of things. Recently, we had a very successful event in Mysore called Pingala Interactions in Computing, connecting laureates, some of them are here, with young researchers. Okay, and ACMW conducts what is called this grad cohort, hugely popular event to discuss about PhD student-centric issues. For university teachers, that's a huge population in this country who are beyond these institutes. We have what is called a teaching partnership program, and there is also an annual education conference called Compute, exclusively discussing about issues in education, pedagogy, curriculum, assessment, various tools people come up with in improving teaching of particular subjects and so on. And the high end of the spectrum, researchers and practitioners, who are the real people who contribute to all our previous events I mentioned, summer schools and rocks. But there are also events targeted towards them. There is this, Yanis mentioned about 38 SIGs in ACM. We have 3 SIGs, one devoted to education, one devoted to databases, and one devoted to software engineering. And they have their own annual conferences. We have webinars, boot camps, mini graphs. And again, if you don't know what that is, I'm not going to take my time to explain. Ask people, check the website. So I said we have 15 council members. Every council member chairs a committee, and we have about 10 or 11 committees. Some of these committees, there's a committee for liaisoning with industry, there's a committee engaging with chapters, there is a committee engaging with other academic organizations, there is a committee ensuring that in all our activities there is diversity, equity, and inclusion. And there is a committee which is a steering committee for all the awards you will get to see in the award ceremony pre and post lunch. We have an active institutional partnership program through which corporates can associate with us on many of our events. They sponsor events. Sometimes there are some institutional partners. Again, you will see in the banners about our institutional partners. These are corporates who have just given us funds of various types for all our activities. And I already mentioned about a very active ACM India Women Committee who conduct a lot of these events. I touched upon some of those events, but they also have a lot of these events. So hopefully it gives you a flavor of the kind of activities, and I haven't really touched all the activities we do, okay? So if you've already participated in some of them, there is a lot more you can participate. There are a lot of opportunities for you to contribute. And as I said, it's a voluntary organization, so we rely on volunteers in the council and outside the council. You know, there are many volunteers even here. They are the foot soldiers running all of our activities. Let me conclude with one last important announcement, that it's an election time, not just for Indian Parliament, it's also for ACM India Council as well as in ACM. And if you are a professional member, you are eligible to vote, not just in ACM India, but also in the ACM elections. So if you are a professional member, please vote. If you are not, please become a professional member and vote. Okay. And with that, I will say thank you. We always welcome comments and suggestions.
Hello. So good morning, everyone. And thank you, ACM, for giving me an opportunity to host Bob. And Bob doesn't need any introduction. I think everybody here heard about Bob when you were studying computer science in your undergrad. He's the inventor of Ethernet. I think one of the technologies in our lifetime which has unified humanity better than anything else. So my true pleasure to be here with you, and my job today is to be as quiet as possible and let Bob speak. But to summarize, I think Bob is a researcher, he's an engineer, he's an entrepreneur, and he's a visionary. So I'm going to try to divide up our 1 hour today to give adequate time to cover each aspect of Bob's personality. And with that, let me kind of begin the conversation to understand the journey of Bob, starting from grad school days. How did you land up at the opportunity where you could invent a technology as powerful as Ethernet? So over to you.
Thank you very much. Good morning. Good morning. Thanks for asking that question. I was a student at MIT, undergraduate, and I graduated eventually, but not before building a connection between MIT and the ARPANET, which is what they used to call the internet at the very beginning. And so I built this card. And I had just learned digital electronics at MIT, so I knew how to build that card. And it was my baby step into networking. Then I went to work at Xerox Research in Palo Alto. And of course, they asked me to build another one of those cards, the one I had just built at MIT. So I built one for Xerox. And then the lab decided to build a personal computer. And since I had just finished building these two cards that did networking, I got the job. Think of the job that I got. For the first time in human history, there was going to be buildings full of personal computers with one on every desk. And that's not impressive to you today, but it was really impressive in 1973. No one could figure out why you'd ever want to put a PC on a desk. But that project needed a network, and I got the job because I was the networking guy. So that was perhaps my biggest stroke of luck, getting that job. So I found a man named David Boggs, a grad student at Stanford, and he became my partner, and we built the first Ethernet. And the Ethernet was it was a one-year project. I thought it was a one-year project. It turned out to be a life's project. But during that year, David and I put together, we had a constraint. This is an engineering thing. We had constraints. One of them was, whatever we designed had to fit on a card this big with 60 chips on it. And it couldn't be 61 chips, because that would be hard to make. So that was a constraint. We had a series of constraints. But the goal was to connect these PCs, and we were building a laser printer. I wrote the operating system for this laser printer, and then they gave me the job of networking the laser printer. This laser printer was a page per second at 500 dots per inch. So it needed a substantial network, so we used the same network for the PCs as the printer. And then the PCs could use the printer by using Ethernet to send their documents over. That was probably the killer app of Ethernet, was printing. And Ethernet, what we chose is my answer getting too long?
No, sure. I will interrupt, no worries.
So I went to the University of Hawaii. I spent a month there, I recommend it. And they had a network called the Aloha Network. And it was a packet radio network. And in that month, I learned two things. One, Ethernet could not use radio. The semiconductors didn't exist. The semiconductors we enjoy today for Wi-Fi didn't exist. we had to wait 25 years for the semiconductors to exist. So Ethernet couldn't be radio. Oh, the radio modem was this big. The PC was this big. It didn't fit on the card, so no radio. That's where we decided to wait for the semiconductors conductors to come 25 years later. And the other thing I learned was the Aloha network had a great method for putting, for stations to take turns sending their packets on the network. So we took that technology, that idea from the University of Hawaii. And those three, there were three technologies. One of them was the coaxial cable that we chose instead of radio. And one of them was the Manchester encoding. We put these packets on the coax by wiggling the voltage, but we didn't want to have a global system clock. It was pretty standard then for communication systems to have a global clock, and they're a pain in the neck because you're always having to synchronize them. So we used Manchester encoding, which put the clock in the packet. Each packet carried its own clock and clocked itself into the shift registers. And then the third technology we had was, as I just mentioned, the Aloha network. All three of those technologies are gone now. So Ethernet has blossomed without those three specific technologies. And what's replaced those three, and now I'll stop. Ethernet brought packets to the desktop. And we didn't really notice how important that was. But before Ethernet, the packets would stop at the computer center in the host, and then it would run the apps over there, and then it would talk to you through a dumb terminal. But with Ethernet, the internet packets would come in and be forwarded to them if properly addressed. And so you had the internet, you could write computer programs to develop applications on the network. A good example of that would be the World Wide Web. The World Wide Web was put on top of this plumbing, this Ethernet plumbing. The second thing Ethernet did was to introduce bandwidth abundance. The Ethernet, the Xerox Ethernet one on my desk was 10,000 times faster than the network that it replaced. Not 10%, not 10 times, 10,000 times faster. And so after Ethernet, bandwidth was considered not so scarce anymore, but abundant bandwidth. And then the third thing that Ethernet contributed to was it joined the list of standards. The internet was really a standards initiative. And at the bottom of all the TCP standard and the IP standard and the FTP standard and the HTTP standard, at the very bottom there's an Ethernet standard. So that was the third thing that Ethernet did. Is that enough of a, that's kind of a long answer, I'm sorry.
No, good. So I'm curious, at that time, some of the decisions that you took were a function of the constraints you were dealing with in terms of technology, what silicon was available. But a naive way of thinking about building local area network is to kind of create a TDMA system and have people go in each slot. But Ethernet is very different. It has taken a very radically different approach to doing it. So how much of the design was a result of deep thinking about how this protocol needs to be designed versus something that was a result of the constraints that you're dealing with from a technology standpoint? Because this technology has survived for a very long time. I mean, usually we are living in a world where things become obsolete in 3 months. And here we are sitting 50 years later, technology is still going strong and progressing. So something deeper about the design that is there, why it has withstood this test of time. So I'm curious if you want to reflect on what are some of those core design principles.
Well, instead of the idea of carrying information in packets, a series of bits, a destination, a source, packet type number, a checksum, that's a packet. That was not an Ethernet idea. That was an internet idea. That was an ARPANET idea. So the tone had been set. We were building a packet network. and all the communications would be organized around packets. In fact, we later discovered it would be two levels of packets. There's the packet, when you send a packet, it has a local destination over there, but it has an ultimate destination, which could be around the world. So there's really a two-level internet packet structure. Ethernet didn't invent that. Ethernet fit into it. And so Ethernet carries those packets for higher level protocols. And as to the durability, you mentioned TDM.
Yeah.
It was, for a couple of decades, it was my life's goal to remove all TDM from the surface of Earth.
So maybe, yeah, let's
It
hear about
it was called SONET, and it was synchronous optical networking, and Ethernet went after SONET, and I think we won. I think we've killed SONET competitively.
And why? Why above TDMA? What's wrong with it?
Two things, well, probably 10 things, but two that I can think of. One is the TDM allocates bandwidth over long periods of time, even when it's not being used. So you're on the telephone and you stop talking, TDM is still wasting bandwidth. Whereas if you stop talking into a packed phone, it stops sending packets because it doesn't have anything to send. So part of it is multiplexing and compression. But another benefit is switching. So the switching rate of a TDM network, that requires round trip opening of a connection, closing of a connection. But the packet switch mechanism, you can switch packets in different directions per packet. And that, of course, enables things like Google and Facebook that have tens of millions of people coming at them at the same time. The switching function, that is, of getting the packets to talk to that machine, now that machine, now that one, is built into the packet scheme.
So changing the subject a little bit, tell us a little bit about your days at Xerox PARC, because as students of computer science, we hear so many great innovations coming out of that center. What was it like to be in that place at the time when some of those technologies were being invented? And how much of, do you think, being in that environment makes a difference? Because you remarked that you were at the right place at the right time. That was one of the key things. I'm curious to know, in addition to that, how much does the environment plays a role in kind of making the person the way the person is?
So my version of a longer answer to that begins with a man named Robert Taylor, a Texan, I might add, and a graduate of the University of Texas. And he got a job managing the computer science research of ARPA. So he was the guy giving ARPA grants to all the computer scientists in the world. And one day, he got recruited away from ARPA to Xerox. So Xerox was a copier monopoly and had lots of resources, and decided to build a lab, a new lab, to develop the paperless office of the future. And did some research, decided to put it in Palo Alto, decided to get Bob Taylor to come and build it. And since Bob Taylor knew all the computer scientists in the world, he was especially good, present company accepted, in picking out the good ones and recruiting them to come to Palo Alto.
So he found you and asked you to come over to PARC?
Yeah, that's right. Actually, he did more than that. So I got a job offer from Xerox. I was working on my PhD at Harvard. I submitted a draft of my dissertation, got the job at Xerox. My wife got a job. She left MIT, got a job at Stanford. My parents were ready to come to Harvard Yard to see their son get his PhD. And I failed my thesis defense a week before commencement. It was horrible. But I had to call up Bob Taylor and tell him that I failed. I didn't get my PhD like I hoped. And he said, Dad, why don't you just come out here and you can finish it while you're here? You saved my life. It was his principles of management of research that made the success that you asked about. He wanted Xerox PARC to be like a university laboratory, and most of the the researchers at Xerox PARC were Stanford professors, including me. And so I think he judged properly that being near a university was important. And he had a very light touch. I'll tell you one story where we were having, David and I working on Ethernet, were having trouble getting it to work. We were debugging it. And we had an adversary in the lab who shall remain nameless. He and I hated each other. And he saw that Ethernet was not working. So he announced, and he was way senior to me, he announced XNet. He was going to do XNet. And this was very bad news, because he was going to suck all the oxygen out of the lab and kill Ethernet. And his XNet was 16-bit parallel, 32 wires in a cable this thick. It was a bad idea. So I went to Bob Taylor, crying, make him stop, make him stop. The next day, XNet stopped. So I go to Bob Taylor, I say, hey, thanks a lot for killing XNet. It was a really bad idea. He said, oh, I didn't do that. I didn't kill XNet. 30 years later, I got him to admit that he actually had killed XNet, but he didn't like killing it. It was a violation of one of his, it was too heavy-handed. I think the thing that pushed him over the top is that this was really a bad idea, born of revenge. The two of us hated each other, so he came up with XNet, not because it was a good idea, but he was attacking me personally. And Bob put an end to that. Anyway, my general answer to your question is Bob Taylor. A slight elaboration, you just had Palo Alto and Stanford, and Bob's access to the best computer scientists in the world, that led to this beautiful place.
Which is Xerox at that time came up with some amazing inventions. I mean, the whole personal computer, mouse, the LCD screen, Ethernet. But we all know that none of these could be commercialized inside Xerox. People had to kind of step out to really build businesses around it. So maybe throw a little bit of light that why an institution which was so successful in fostering such great ideas couldn't take it to the commercial success.
Well, there's a double-edged sword called monopoly. And I've already mentioned this. I should have mentioned that Xerox was a copier monopoly and had a lot of money. And that enabled it to create this lab. So in that case, monopoly was enabling. But then when the products came and we tried to enter the computer market, we had a company that was a monopoly entering a fiercely competitive marketplace. And the market just chewed us up and spit us out. I mean, it was, so that's my answer. Monopoly, the double-edged sword. Monopoly made this thing possible, but it also made it hard to compete once we had real products. My colleagues that I work with like to use the third person. They like to say they failed to commercialize. They did this and that. And I have to remind them, wasn't that us? Weren't we there at the time? Weren't you in charge of that? No, they, Xerox failed to capitalize. By the way, Xerox did capitalize on a lot of, just not, it didn't turn out to be Apple or Google, but it was still I think a successful venture. It should not be used to discourage corporate research.
So tell us a bit about what prompted your exit from PARC, and when did that happen, and the story of starting 3Com and commercializing this idea of Ethernet.
So I arrived at Xerox. I got my PhD from Harvard. Of course, it took an extra year, and became a researcher. And so for 4 years, I was in the Xerox Palo Alto Research Center in the computer science lab. And then I left that to join Xerox System Development Division to commercialize the products we had developed in research. I did that for 4 years. Oh, I left Xerox twice then. I left Xerox after the first 4 years, and then I left Xerox after the second 4 years. And good learning there. When you leave a place, don't slam the door behind you. You'll be back. And I was back. Twice, actually. I came back after leaving the first time, and the second time I won Xerox as a customer for my startup by not slamming the door behind me as I left. And, oh, so now to your question, why did I leave this? I left the first time because all my friends were making more money than I was. And it was and they had MBAs, mere MBAs, and they were making more money. So, youthful person, I left Xerox and increased my salary by 25%. But I hated the new jobs. I only lasted 7 months, but I convinced Xerox to recruit me back. And of course, when you recruit somebody, you have to pay a premium. So I got a 25% raise coming back. So I got a twofer. I got and this, at Xerox, this was called a Metcalf. You're pulling a Metcalf. You leave to increase your salary, and then you come back and get an increased salary. It's called a Metcalf in employment
Has
technology.
anyone played Metcalf on you at 3Com?
Well, I tried to fight this Metcalf strategy at 3Com. At 3Com, it was our policy that everybody should be competitively paid. It was our job to be sure that all our employees were competitively paid. And if they got a better offer, we would not respond. The principle being this employee is already competitively paid. He's getting this silly offer from somebody else, and we're not going to match that. Yeah. That was our policy, and I think it worked pretty well. But it did put the onus on us to be sure that our employees were competitively paid.
So tell us the story of 3Com. How did 3Com start? And
okay, so when I left Xerox the second time in January of '79, the memo said, I'm leaving Xerox, quote, to pursue entrepreneurial ambitions, with no clue as to what they were. And in February of that year, '79, I had a meeting with Gordon Bell of the Digital Equipment Corporation, and he wanted an Ethernet for the second largest computer company, DEC. But I declined to do that, and instead got him talking to Xerox about using Ethernet to connect DEC mini computers to Xerox printers. And pretty soon we had the idea called DIX, D-I-X, DEC, Intel, Xerox, to build an Ethernet that would use Intel semiconductors to connect digital computers to Xerox copiers. And then the US government came in and said, you can't do that. It's a violation of antitrust law. You cannot be in the same room. It so happened that my roommate in college was an antitrust lawyer, Howie. So I called up Howie, presented him with this challenge. I wanted these companies to meet, but the lawyers wouldn't let them. Howie gave me a checklist of how the meeting could be arranged. And one of the key features was if you were meeting to create an open standard, that was okay. So no marketing people are allowed in the meetings. There needed to be a government observer. And you had to be working on an open standard. So then we didn't go to the ACM, we went to the IEEE and created project, I don't know why, does ACM have standards?
No.
Oh, so that explains it. Not yet. Oh, 4.0, who knows? So we created Project 802 at the IEEE to standardize the DEC Intel Xerox Ethernet. And that IBM, meanwhile, noticed this. So IBM was announcing it, as it usually did in those days. It would just announce products. And it had announced SNA, System Network Architecture, which was completely proprietary. By the way, I used to call it SNA, just to annoy IBM. But IBM noticed that customers were liking the idea of having a multi-vendor LAN standard, local area networking standard. So they said, we better have one too. So they ran off and they found one called the Token Ring, and they showed up at the IEEE. And that started a huge war that lasted 20 years as these standards competed. The IEEE caved and standardized Ethernet, token ring, and token bus. So there were 3 IEEE standards. We killed token bus very quickly, but it took us 10 or 20 years to kill the IBM token ring.
Did Apple Talk have any role to play around that time at all, or was not in the play?
In June of '79, I got a call from Steve. Had a company called Apple in a city called Cupertino, and I'd not heard of any of those 3 things, including Cupertino. It's kind of funny. It's not that far from Palo Alto, but I'd never heard of Cupertino. And this kid needed a networking expert for he was making PCs. So I declined. But he helped me build my company. Wait a second, what question am I answering?
Yeah, I said, did Apple Talk have a role to
Yes.
play in that time?
So I turned Steve down and presented him with a proposal of a network that I would sell to him. And I called the network Orchard. Get it? Steve didn't get it either. But he helped me start the company. He did not buy any orchards. And I didn't get him to adopt Ethernet until after, at Next, the Next computer had Ethernet, and so did subsequent Apples. So it was a hard sell. So he recruited the guy who worked for me at Xerox, Bob Belleville, and Bob then built the Macintosh. And they needed a network, but Bob Belleville wanted to use a standard chip. While we were waiting to build Ethernet chips to run at 10 megabits per second, there was this much slower existing standard product, and it was fast enough, and that was called Apple Talk, and it competed with Ethernet for 10 years.
So 3Com, when was it incorporated as a legal entity? And
3Com was incorporated on June 4th, 1979, and became part of HP in 2010.
so when I was reading about 3Com, what surprised me a little bit, I would imagine you as a CTO or CEO of 3Com, but you are running sales. So I'm curious, what sort of prompted your transition from a Ethernet inventor to actually driving the sales in an organization?
So we raised some venture capital, we built some products, we started selling them, and yet we were consuming cash. And this is a familiar chart. Cash, like this. And down here is 0. And when cash hits 0, all sorts of bad things happen. Never do that. So 3Com was going like this. So the board of directors of our company had to do something. And by the way, I recruited all of them. They were really great people, and they announced that I was no longer going to be the CEO of my company. Instead, I was going to be VP of sales and marketing. And take that as a measure of how desperate we all were. They took the engineer and made him head of sales and marketing. But the thought there was networking was high tech and very technical. And I could get an appointment with the VP of engineering of a customer because I invented Ethernet. So the idea was make me the head of sales and marketing, and then I could be successful selling. And I don't know if you're familiar with this, but that would be called a bad decision with a good outcome. It succeeded. So 2 years later, we went public with $1 million. I got us to $1 million a month. And I learned how to sell, and I learned how to run a sales
Especially
organization.
if you're selling a vision, you're trying to convince something that people have not imagined or they can't think about. You have to be almost an evangelist to really get that idea across, especially at a time when people didn't fully understand what value a network could bring.
Right, Ethernet was designed to network personal computers, and the problem was there weren't any. So we sort of all of us had to wait for the PCs to come, and IBM came to the rescue with the IBM PC in August of 1981, And then we put all those we developed the capability of putting all those IBM PCs on an Ethernet a year later in September of '82. And then we went public in March of '84. So there was really, there's IBM has another role in this story, which is they saved the day by introducing the IBM PC. And thereby making Bill Gates the richest guy in the world.
So tell us the story of Metcalfe law. Okay, I think that was invented when you were running 3Com, right? What are the circumstances where that insight came and?
Okay, so we're selling cards that plug into PCs to put them on a network. And there weren't any PCs. So we made a trial. We wanted to make it easy for people to try this. So we made a 3-node network, 3 of our cards, a length of cable, and a diskette for $3,000. The customers would then put PC string cable along the 3, and then load the diskette software into each one. And then the 3 PCs could share a disk, or share a printer, or exchange email. We sold a lot of these. People were curious. But then they reported back that this configuration worked, but it wasn't useful, which is seriously bad news for the VP of Sales and Marketing. So I went over to Stanford University that night, and I found the PC that we Xerox had donated to Stanford, and I used it to make a slide. And the slide said, the cost of the network is linear like this, but the number of different connections you can make goes up as the square, this. And if there's a crossover point here where the value begins to exceed the cost. And then I made 6 35mm slides because there was no PowerPoint. I was on the board of the company that did PowerPoint, and we sold it to Microsoft in 1987. This is 1981, 82. The slide said, the reason your network is not useful is that it's not big enough. And the remedy for that is to buy more of our products. And they did. And we went public on that basis alone. And the value was there. I mean, these networks panned out. It was a risky thing to try, but they worked, and they proved to be useful. So the question arises, since I was head of sales and marketing, was I lying when I made that slide? And the answer is I wasn't lying. I had been at Xerox for 8 years in that future with local area networks of personal computers and laser printers and all that, and we could see that that was good. So we weren't lying when we started selling our products. We knew that they were valuable.
So if I hear your story until now, you spend some few years of life in a research environment, inventing, creating things, and now you're out in the market trying to sell, survive, bring in revenue, which sounds like a much more intense journey. So given the 2 phases of your career, if you had to contrast, which is the one that you really, I mean, for our, new students and, aspiring entrepreneurs and researchers, what sort of the lessons learned from these phases? And because we were discussing over breakfast, you said, especially you had a remark about the entrepreneurial phase that, do it at your own risk. So curious to hear.
Now that you asked, there's sort of 2 ways of living. A research scientist doesn't have an alarm clock, gets to work in time for lunch, writes papers. It's a nice life. When I was at Cambridge, England, I was there for a year. And breakfast becomes morning coffee, and then it's lunch. And then lunch becomes high tea, and then high tea becomes dinner. You spend your whole life eating all that. And then over here is the life of a salesman. And it's fierce, it's competitive, it's bad for you physically. It's costs you a marriage or 2. but you're changing the world. You're having impact, and that feels good. But you can't compare those two lifestyles. They're just different. So I'm lucky I got to do both. Oh, so the key that I learned, and I had to make that transition from engineer to salesman, there's a secret thing I know I'm going to share with you right now. Selling. Success, I found success in that role by learning how to sell. And I hadn't really learned how to sell prior to that. I didn't take selling, I didn't get an MBA, and I didn't take sales skills. I learned how to sell in front of customers. And now I can tell you the secret of selling. This is very hard for me because I talk a lot. And the secret to selling is listening. And so, Bob, stop talking. And I learned how to do that, how to stop talking, like right now.
Yeah, I think we will change gears a little bit. Now, story has reached up to 3Com, company is successful, gone IPO.
Okay, so in 1999, my little company, without me, I left earlier, I left in 79. My little company was worth, inflation adjusted, $70 billion.
Wow.
But I should point out it only stayed there for a few days. And then the internet bubble burst and all the stock prices went like this. But the company really, that whole generation of networking companies, Cisco and Juniper and others, boomed during this period. And then, and they're still there. The bubble burst, but they're still there.
Yeah, yeah. And 3Com was at the right place at the right time in some sense. I mean, when the internet was really booming, could it have become the Cisco?
Cisco?
Yeah, because...
Yeah, Cisco's a special case. Cisco was founded the month we went public. One of our board observers, who was on my board of directors for years, a venture investor, resigned from my board and went on to the board of Cisco. This brand new company that was starting. And 3Com was bigger than Cisco for a very long time, years and years, and then Cisco just blew past. And John Chambers did that. John Chambers knew how to do something that I've already mentioned. He knew how to sell. And he sold those Cisco routers, and they blew past 3Com. And 3Com was a multi-billion-dollar company, but it wasn't Cisco. Right. And so we ended up as part of HP.
So I was looking at your Turing Award lecture, which you gave some time ago. And that lecture actually starts with you taking a very bold kind of a statements about connectivity as the key thing, which has emerged out of Ethernet. So next few minutes, let's I think spend some time, kind of help us, bring us to that level of understanding of where do you see connectivity moving, what lies ahead in the future, and help us sort of get to some level of understanding which you've already arrived at through your own thought process of the connectivity as a paradigm.
Well, let me first thank the ACM for giving me the Turing Award. I'm humbled, and I take it as an opportunity to be more dignified and well-behaved and do God's work. So thank you, ACM. But then I then knew that I was going to give this Turing lecture, and I decided, by the way, although ACM doesn't know this, I have planned to give the Turing talk 50 times, and I've only done it 10 so far, so I got 40 more to go. And it had to be organized around the major learning that I did in the career leading to the Turing Award.
Yeah.
And I concluded that and this is a sentence, I wouldn't change a comma of this sentence. The most important new fact about the human condition is that we are all now suddenly connected. And a lot of what's going on in technology and in the world can be explained by the features of connectivity and how the system is related. So the internet is continuing to boom, and we're now making the transition from the megabit internet to the gigabit internet. It's happening right now. But then when you look into the story of connectivity, you discover it's full of surprises. And the talk is about enumerate some of the surprises of connectivity. And that means that and the surprises are not going to end now, they're going to continue. So we have to be prepared. When you work in connectivity, you have to be prepared for surprises. Just as an example, a man named Herb Grosch, may he rest in peace, worked at IBM, and he had a law way before Metcalfe's law. And his law said, in essence, bigger computers are better. And he had a chart that showed all the IBM mainframes on a graph and showed their cost going up as the square root of the power. Bigger computers are better. And that law was adopted by IBM and by DEC and by Data General and by all the East Coasties. Meanwhile, there was another law called Gordon Moore's Law, which basically said networked PCs are better. And Gordon was right, and Herb was wrong. And so Silicon Valley moved from Boston to Palo Alto. In fact, I think it was on the same plane that I took from Boston to San Francisco. I think Silicon Valley was sitting right next to me. Where was I? Oh.
Yeah. So explain the whole connectivity, it brings about disruptions.
Okay, so
yes.
Turns out not all connectivity is internet. There's other kinds. And one of my favorites have you heard of this new buzzword, AI? Have you heard of that, AI?
Yeah.
So I'm arguing that AI is not the thing. Connectivity is the thing. And the way I make that argument is to show how it's connectivity that makes AI. Neural network. Oh, network, that's a connectivity word. And there it is right at the core of AI. So then you look at there's a paradox in there. That I call it the transistor neuron paradox. Neurons are huge and slow, and transistors are tiny and fast. Let me put some numbers there. Transistors are 1,000,000 times faster than a neuron, and they're 1,000 times smaller. And here's the paradox. We build human brains with neurons, those clunky old neurons, and we have not figured out how to build anything nearly as smart as this with transistors yet. So that's the paradox. And what explains the paradox? How can this be true? How come we can't do better? And the answer is connectivity. The networks are not connected enough. So the GTP4 has 176 billion parameters or connections. They're analogous to synapses in the brain. 176 billion. And we're not close to AGI with that. And its arithmetic will point out why. We have 10 to the 11th neurons, each of which has 10 to the 4th synapses. So that's how the neurons win. The connectivity of a neuron is enormous with its 10,000 on average synapses. So we're going to have to increase, my theory is we have to increase the connectivity now of our networks. So I asked OpenAI, will your next GPT have, say, 100 trillion connectivity? And of course, they said, we're not at liberty to answer that question. So my theory is connectivity is going to lead the way in AI. And as we
But
add
actually, this connectivity that you're talking about, do you think Ethernet can evolve to meeting this need? Because this seems to be a very different type of connectivity, extremely high interconnections, because Ethernet architecture is still very much now a central switch with spokes coming out. Maybe some fundamentally new technology or approach is needed to attempt something like this.
Well, you raised one question which I've sort of not made much progress on, but is some form of Ethernet-ish connectivity applicable to the neural net?
Yeah.
In other words, can neural nets begin to communicate by switching packets through their trillions of connections? And I don't know the answer to that. Certainly there'll be connectivity. As to whether it bears any resemblance to the Ethernet, I don't know.
So I think at this point, I want to kind of maybe open the floor to some audience. If they have any questions that they want to pose while we kind of continue our conversation. How much time do we have? Around 10 minutes? Yeah. Anyone in the audience, just raise your hand if you have any question that you want to kind of pose. So while, yes, please.
Hello, this is Prashaman. I am doing my graduation in mathematics, so this is particularly interesting to me. That what motivated you to take a applied math master's degree after coming from a engineering or industrial background, and how did it help you in future? Thank you. I'm sorry.
I did not hear that.
Closer to the mic and see it again.
Yeah. So my question is, what motivated you to do a master's degree in applied math coming from an industrial or engineering background, and how did it help you in future? Thank you.
Thank you, but I still didn't hear you.
I think the question is, what motivated you to do a master's in applied math?
Yes.
And then later,
How did it help?
yeah, how did that training in applied math? Are you an applied math student by any chance?
I'm pure math, but I'm doing my graduation.
So what was the question?
Question is, what motivated you to do a master's in applied math?
Oh,
And how did that help you to do what you ended up doing?
to make a long story short, in 1969, when I graduated from MIT, MIT called computer science, called it electrical engineering. So I have a degree in electrical engineering, which is equivalent to a computer science degree today. Harvard, on the other hand, called computer science applied mathematics. So everything I did was computer science. It just had different names depending on what school you were at. And eventually they figured out, Harvard hasn't figured this out yet, but so my master's degree is not only in applied math, which is not quite right, it's also in Latin, which is wrong too. Whereas my MIT degree at least says electrical engineering, period. So it was just a naming, it was a naming thing. And the applied math there was, for example, proved theorems about Turing machines. We did recursive function theory and lambda calculus and Turing computability. But to be honest, at the same time, I'm down at MIT building this card with 60 chips on it with dual inline packages and voltages and stuff while taking the applied math courses. And it worked out very well. I needed both skills to do Ethernet.
Actually, one question I want to ask you, if I look at the trends these days, most of the computer science undergrads are finding great jobs right after their undergrad. And there's a startup culture is also on fire. So there's an urgency to get out there, build a company and be out in the real world. The number of people who really want to pursue masters and PhD is kind of declining. And I'm curious, what is your take? because it's a investment that people have to make to kind of go through that grind, which prepares you in a certain different form and shape. And having seen now the trend of the last 50 years, what's kind of your advice and take? What is the right thing to do?
That depends on who you are and what you're interested in doing. But to go to my case, so my parents were prepared to pay for my college education, and MIT was $1,700 a year. And so my parents wrote checks for that, and I made it a priority to relieve them of that responsibility, so I went and got a job. So I didn't wait till I graduated. I had a job sophomore year at MIT. And it was midnight to 8 every day. I had a full-time job out in Wayland, Massachusetts. Then I would go into MIT during the day and take the MIT courses. So I jumped the gun. I was 4 I had a job all through college. And I think I learned as much from the job as I did from MIT. Do I answer your question yet? I'm not sure.
No, so I think you're saying it's very much depends on the person in terms of whether
Yeah.
they want.
So the number should decline.
Yeah.
We have too many PhDs. No, and here's how you can tell. There's a thing called a postdoc. You know what a postdoc is? You go to get your degree, and then for a year or two, you're a postdoc somewhere. Well, not anymore. Postdocs are 2 years, 3 years, 4 years, 5 years. What's happening? What is happening? Well, all of those PhDs want to be professors, and there are no professor jobs available, so they're queuing up. There's just a lot of them. So maybe fewer of them is a good thing. Do you know what postdocs are really good at? Starting companies. So as a venture capitalist, the postdocs have just finished getting their PhDs, they have their dissertations, they've mastered something. There's a good chance you could make a company out of it. So that's how I see how we navigate out of this crunch that we're currently in.
So yeah.
Hello, sir. Thank you for the insightful talk. I'm here. Yeah. My name is Ritvik. You mentioned in the end part of the talk about a buzzword called artificial intelligence. So my question is, what part of artificial intelligence amazes you, and where the field can improve?
In 1968, I wrote an undergraduate thesis for my advisor. My advisor is a man named Marvin Minsky, who is one of the founders of AI. And my thesis was called A Neuron Model and Some of Its Information Processing Capabilities. All copies of that dissertation have been lost, alas. But the point is, I've been watching AI come and go since '68, and it does come and go. And we're on another wave of it. Here it is. The machine learning wave of AI is now upon us, and it's great. But by the way, do you know what was the buzzword just before AI? Does anyone remember? You know, consensus, distributed consensus machines. Blockchain was the word. Do you remember you couldn't go to a conference that wasn't about blockchain? Well, when's the last time you used the word blockchain? Anyway, the same thing's going to happen to AI again over time. But the thing that's going to save AI this time is the internet, connectivity. Because AI needs data. And where's it going to get its data? It's going to get its data through connectivity, through the internet. So I'm optimistic about AI. Even if the buzzword goes away, there'll still be AI. So that's an important lesson, by the way. The buzzwords go away, then the actual real thing may still be there.
So thank you, Bob. I'm getting signals from all around that our time is up. Maybe one more question.
So just a comment that you mentioned about too many PhDs and too few jobs. That's certainly not true in the Indian context. The last couple of days, we had people from universities and industries coming saying, we want PhDs, please come join us. So I just want to make that comment. At least, yeah.
I stand corrected then, at least in the Indian market, yes.
So, one question I have is that I was reading a book on some book on super recursive algorithms. So they were talking about some algorithms which were needs some machine more capable than Turing machine, and they mentioned there's something called distributed computing, like when there's a multiple computers connected through the network, and to model that structure, to write a generalized algorithm for like a distributed computers, we can write algorithms which cannot be solved in the Turing machine model. So, like, can you like anything?
That's a question that really can't be answered on a stage. We have to sit down with a pencil somewhere. But thank you for trying anyway. I'm sorry, I can't answer your question. We're done, right?
Yeah. So Bob, I thank you very much. And Bob is going to be around over lunch. It's full of so much of wisdom and stories. I think we could capture only a few of them. So there's many more, and I'm sure as you meet him over lunch breaks, some more of this will come out. So thank you very much and enjoy.
As a small token of appreciation, a tamarind tree, has been planted in the name of our Turing awardee this year. And thanks to connectivity, there is a QR code here that can be used to track the growth of the tree. I now request Dr. Praveen to hand it over to Bob, please. We now have a break. It's been shortened to 25 minutes because we're overshot by 5 minutes. So please come here by 11:25. So it's a 20-minute break. And the next talk is by Professor Sriram Krishnamurthy. So handing over. Here there are some. We only try for this one. We know what needs is special. Do you mind if I move that laptop out? Yes. Oh, hello. I feel like we're old friends. Can you turn the Microsoft button? No, I'm all good. Thank you. So, yeah, what's the deal? Do you want me to use Zoom? Or? Yes. Oh, you do? Okay, that's going to go off my...
Something came on briefly. completely. I mean, all the fonts look the same. Yeah. The system, your product, most of it. Sorry, I'm just looking at that. Possible solution. I can live with this solution. Okay. So tell me what you, sorry, no, could you tell me what you do? Yeah, yeah, yeah. Right, right, sorry. No, it's not even residual. Thank you. Yeah, that's completely true. That's You're not, I was lucky. I got away from people like how much more can you expect from people at that? It's been better, but it's been worse. I might not. No, 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 no. I like the previous.
Where are we doing it? This side. Okay. With the audience. Excellent. Thanks for coming. Thank you, man. Thank you for having me here.
Requesting everyone to please settle down in their seats. We're running late for the next talk by a few minutes.
Participate in the talk. I'm going to ask you questions. Come. You can read email later. Come. Yeah. That's right. Oh, yes. So, yeah, actually, I would like to try my clicker just in case that should work because it's just a USB. I'm just used to it. That's good.
Hello? Yeah. Okay, welcome everyone. So it's a great pleasure to introduce you all to Sriram Krishnamurthy. He's a professor of computer science at Brown University, and there are two really interesting strands of his work, at least that I know of, right? So first, he's a co-founder of the Bootstrap project, which integrates computing and data science into multiple subjects in the school curriculum. And Sriram, I don't know if you know this, but we actually presented that model to the NEP committee, and in some way, it has made it through to at least the maths curriculum, right? We're following Tamil Nadu, which has already started this, right? The second interesting strand of his work, and I think we'll see elements of that in today's talk, is he's blended computing education and other sort of technical areas like programming language design in ways that I think are really, really remarkable. So he takes challenges from the education space, challenges in computing education, and then he develops technical solutions to those challenges, and then those solutions themselves sometimes, have impact way beyond computing education, and Racket is an excellent example of that. So he's received many, many awards, just a few: SIGPLAN Robin Milner Young Researcher Award, SIGSOFT Influential Educator Award, and the SIGPLAN Software Award. So Sriram, thanks so much for being with us. Look forward to your talk.
Thank you for the invitation. I don't think that. Yeah, no. Okay. People in the back, can you raise your hands, please? Good. That means the people in the back, are you reading an email or can you not hear me? Okay. You're not reading, you were reading your email. Okay, very good. Urj, thank you for the very kind introduction. ACM India, thank you for having me here. I know, as those of you in the know, it's been a bit complicated getting me here, so I especially appreciate your patience. We're going to start with some work. I'm going to, folks. It's pretty noisy back here. Sorry, I can't hear the audience from here. Okay, good. So we're going to start with some work. I'm going to give you a little bit of homework. I'm going to give you a little problem, and you're going to yell out the answer, okay? Yes, you're good? You good with that? Okay, so I'm going to show you formulas, and you're going to tell me under what circumstances, for what values of A and B, are these Boolean formulas going to be true, okay? Okay, so yell it out, yell it out. I want to hear all the students. Professors are all fine. I want to hear some students. Good, 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 good. True, true. A and B are both true. Yes, good. Okay, good. All right, here's another formula. Oh, yeah, so in fact, there seem to be how many solutions? 3 solutions. Excellent. A is true, B is true, or A and B are true. Okay, good. You're getting warmed up. You know how this game is played. Okay, one more problem. There are no solutions, right? There are no solutions because you can't satisfy this. Okay, one last problem. Yeah, okay, good. So something like that, right? So what is the point here? This is the problem of Boolean satisfiability, okay? It's one of the classic famous problems in computer science, and this simple technique happens to have huge applicability because you can turn all kinds of interesting questions into Boolean satisfiability questions. So I and several other people have for many years built various kinds of tools for network analysis, security analysis, all kinds of other things, cryptographic protocol analysis. So touching on 2 of the speakers from today, the one before me and the one after me, you can encode those things into questions that can be solved by Boolean satisfiability. Okay? So it's a very, very broad topic. There is a problem. The problem, of course, is Stephen Cook and Leonid Levin's papers, right, which basically said these are, in fact, the canonical NP-complete problems, right? These are in fact, if you look at Cook's paper, SAT is literally the problem he used for reduction. So we can reduce many things to SAT, but in fact, all these things are very hard to solve, right? So this sounds like bad news, like I haven't actually helped you in any way. That is the mathematics. In contrast, there is the engineering, and the engineering is, in fact, we're doing very well. This graph is a little hard to read. You don't need to read the details. The point is, as time goes up, the size of the problem we can solve gets bigger and bigger and bigger. Okay? So we can solve large problems. We can solve practical problems. These things are now embedded in all kinds of settings. Okay? And in fact, the next edition of the next volume of Art of Computer Programming, actually the biggest section is on satisfiability. And what Knut says is the story of satisfiability is a tale of the triumph of software engineering blended with rich doses of beautiful mathematics. There's actually a third component. Anyone guess what the third component is? Software engineering, mathematics, and AI? No, 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 no. Even AI needs something to run on. Hardware, okay? So there's three things that have led to these graphs looking very, very nice. Okay? So that is satisfiability. I want to tell you about one particular perspective. I happen to be a big fan of this thing called Alloy. It's presented in this book by Daniel Jackson and the rest of his team. And I want to give you a feel for what it's like to work with a system like Alloy. And that will be the starting point from which we can talk about the research that I want to talk about today. Okay? So here's what Alloy looks like. It looks a bit like an IDE. I don't want you to read all of the code on the board. I just want you to look at it and say, oh, you know, it's got some curly braces. It looks a bit like Java code, right? Curly braces are good, right? Curly braces make us feel like code, right? So it looks like code. And what we've written here is a specification. We've written an idealized description of, in this case, a binary tree, okay? So we've tried to describe binary trees. And then we're going to ask, is this in fact a binary tree? By writing a property, okay? And in this property, we're saying that a binary tree means that it has a unique root node, okay? Now, the great thing about these tools like satisfiability solvers is you can translate this down into mathematics, and then you can click on a button over here. It's called execute, a run button, and it runs. It's kind of like writing a program in an IDE, right? You run this, and it's going to come back and say, well, actually, it's going to come back and say, not quite. Here's an example. Here's, in fact, a counter example, okay? Here's the counter example, right? Is that a binary tree? Why is it not a binary tree? Yeah. Any other reasons it's not a binary tree? So some people, those of you who can't see, some people are doing this, right? There are loops. You can't have loops in a binary tree. Another reason, yes, is this, right? You have sinks rather than sources in your binary tree. So it's obviously not a binary tree, okay? So we have a nice concrete counterexample. So now let's say I go in and I make some changes, okay? I'm going to edit something, and I run the verifier again. It comes back and says, no counterexamples found, right? Great. Verification, at least for this one property, is succeeded. But the reason I'm excited about these solver technologies is because I can do something else that is very interesting, okay? The very interesting thing is, let's say I have this specification and I have not yet figured out what properties I want to check, okay? I'm still in the process of inductively building up my properties. Then I can just say, show me some examples of the specification, okay? And it comes back and it says, I found you some. In fact, I can click on the word instance and it comes up and says that. Is that a binary tree? Why is it not a binary tree? Well, this, right? There's also something else going wrong with it. Yeah, there's two things that are pointing to the same node, right? So the thing is, by looking at these concrete examples, we can start to infer, like, what are the ways in our spec is broken, and then turn those into properties, check them, and think of it as in an iterative process, right? So this is a very lightweight way of building up formal specifications. Some people call this lightweight formal methods. It's a very powerful idea, okay? Now, that's the good news. Now I'm going to tell you about the human factors, right? So far, we've just been in the realm of mathematics and engineering. Now I want to talk about the human factors. I'm going to focus on 4 questions. What do we compute? What do we show? How do we show it? And how do we write these specifications? Those are the 4 areas I'm going to dive into, okay? We ready? We're good? We're good? Everybody with me so far? Excellent. Good. Okay, so let's start with what to compute, okay? So I told you that the underlying engine, the underlying technology is a satisfiability solver, right? I give it a formula, and it does what you did at the beginning of the talk. You were all satisfiability engines, right? You came back and said either it's not satisfiable or you gave me concrete instances, right? So the output that you get from these is a satisfying instance. That's all it is, nothing more, nothing less, okay? That's the spec. We ask for one, we get that, and basically we have these black box algorithms and we get whatever the black box algorithm generates. That may not be exactly what we want. In fact, if you look at Jackson's book, he has the following text in there. He says, though the selection is arbitrary, in practice, the first instance generated tends to be a small one. And this is useful because small instances are often pathological and thus more likely to expose subtle problems. Okay? And I mean, it makes sense, right? If you think about it, if I give you some ginormous example, you might not see what's wrong. If I show you a nice small example, you're going to be like, yeah, okay, I see what's going on, right? Anytime you've written a proof, right, you've had your professor tell you, shrink it down, bring it down to its essence, bring things down to their essence. That's a good universal principle. Okay? All right. So we did this. We built multiple systems that we called principled model finding, which is we try to have the output satisfy some stronger theorem. Okay? And one example of this is a system called aluminum. And I'm sorry, there are going to be some very bad metal jokes in this talk. Okay? So aluminum because it computes the minimal models. Okay? And then there was another system called amalgam, which tries to give you the provenance of models, whatever that is. We won't get into that very much today. Okay? And I know this is like classic academic success, right? These were published, they were at major conferences, one of them won a Best Paper Award. This is all great. Okay? But I'm here to really tell you bad news. I'm here to tell you why my research was not very good. Okay? Here's why my research was not very good. What happened is we started to look more closely at what we were saying. And if you read our papers, they say texts like, when given confronting scenarios, a user can be confident in something. Or an amalgam, it's crucial that tools empower users to do something, right? And anybody who's written an academic paper has written text like this. We all write text like this, right? Everyone's looking, in fact, all the theory people are looking a little guilty at this point, right? Yeah, of course, that's the first page, but nobody reads the first page. It's okay, all right? Okay, what if we take the first page of our paper seriously? Okay, what if they're not just fillers? So we wrote this other paper, and this paper did not win any awards, but it's far more important than the ones that did, because I think this has pointed me in a new direction for how to think about my research. So what we did was we said, let's take all these claims. So I told you about provenance, I told you about minimality, we took some other mathematical structures as well, and let's try to do some user studies on them. Okay, I'm sorry, we're having some font problems. The X just means a product, the box after it you should ignore, it just means product. Okay, so we did it on multiple subjects. We did this with students, we did it with crowdsourcing audiences, etc. And there's actually a little trickiness there. How do you do like math logic with crowdsourcing participants? If you're interested in that question, talk to me afterwards. But we did this with various domains as well. And here's an example that I don't have to explain very much, which is we're going to look at reference counting as a garbage collection technique. Okay? Reference counting fails as a garbage collection technique because when you have cycles, it breaks down. It can't collect cycles. Okay? So here is an example of the kind of graph that Alloy will produce. Okay? And it's a pretty instructive graph because you can see that the heap is deeply connected, the heap has self-nodes, and that's going to cause your garbage collector to break down. Okay? Yeah, except that's not what aluminum produces. Aluminum produces that. That's not of any use at all for our purposes, is it? Right? That actually actively discourages you from understanding what is going wrong in this algorithm. Or here's another example. This is actually after a few steps, and you can see that there's an uncollected cycle sitting on the heap. The stack is pointing to a heap node that is not referencing those, and so those are going to just like leak memory in your program. Okay? Again, minimal model looks like that, which again takes away all the important information. So we did a whole bunch of these studies, and basically what came out was extremely depressing. Okay? We found, first of all, that most of the students just dropped out of the study. Then they went back to using the default software, right? They didn't want any of this fancy principled model finding output, right? It just wasn't useful to them. They didn't like it. They actively disliked it, in fact. And what's worse is the students who did complete we did the same thing with the online participants as well, but this is with the student audiences. Basically, even when they did, they made all the wrong edits. So where they did use the tool, it actively misled them. Okay? This was very sobering. And basically, we sort of realized that one of the problems here is we were chasing after mathematical elegance. And by the way, people in the audience were nodding along, saying, yeah, minimal sounds like the right kind of thing. And there are some settings where it is, in fact, the right thing. There are other settings where it is exactly the worst possible thing. Okay? So we said, okay, maybe we need to start judging our own claims a little harsher and think about what we're doing here by thinking about combining some of the human factors work that we could do with the mathematics and algorithmic work that we're doing. Okay? So, and I will claim that our literature is full of these kinds of untested claims, and sort of one of my career goals is to start testing those and finding out which of those claims actually work for humans and which ones don't. Okay? So that was the first part, like what are our algorithms going to compute? Next, what do we show them? Okay? So our goal, you've seen some of these examples, right? You've seen some of these pictures. What is the goal here? The goal is we're going to show you some visual output that we're hoping will have some sort of effect on your brain that leads you to make the right conclusions and right decisions. Right? That's our ultimate goal. That's why we show these visualizations. Okay? Well, I mean, that's a deeply cognitive question, right? And we're not the first people to think about this. There are whole fields that think about this. And perhaps there's some inspiration we could be getting from all of these fields, right? There's actually a very, very rich literature, and I'm just showing you a sampling of some of the papers from this literature. So, you know, like Gibson and Gibson is like a seminal paper from the 50s that set off the field of like visual perception. And there's even work older than that. The paper on the top right is about the study of how do people identify the sex of a chicken, which turns out to be something you have to do a lot if you work on a farm. And it's actually a funny paper because the title doesn't say it, but the back half of the paper, it was written in 1987, which will help you understand why it does this. Also helps you identify NATO tanks versus Warsaw Pact tanks. Okay, seriously important questions. Okay, anyway, so the point is there's a literature that spans a whole bunch of areas, both from cognitive and perceptual psychology to educational psychology, that tries to answer these questions. Okay? What I want to do is I want to walk you through an example. Right? So here's what we're going to do. We're going to talk about a society of blobs. I'm not going to tell you which planet blobs are from. You're going to try to tell me something about blob society from the examples that I show you. Okay? We're good with that? Okay, so here is an example. So what it says is, this is a valid dinner party, and so you have two blobs. This arrow says cooking, this arrow says cooking, and this box down here says meal. Okay, what do you, so think for a moment and tell me, what do you infer about blob society from this picture? Anyone? Someone needs to be brave and tell me something. Come on. Once one person says something, other people will follow. They cook together. Okay, very good. They cook their own meal. Other comments? Other thoughts? Sorry? They cook their meal at a party. Any other guesses? Too many cooks spoil the broth. Very good. I like it. You're awake. Okay. Other guesses? Other guesses? Okay. So there's some amount of information you've been able to extract from this picture. Notice these are all guesses, right? We're making conjectures. We don't fully understand blob society yet. This is similar to what happens when you take networking configurations or security configurations that you don't know and you're trying to pass it through an analyzer. You're going to get these instances and you're going to have to inductively infer properties about them because usually the sources are way too large to read and understand. Okay? So we're doing this process of induction. Okay, let me give you a second scenario. Okay? So again, we have blob, blob, cooking, cooking, and meal, but we also have a parent-off relationship going from this blob to that. What does this suggest to you? Sorry? Parents teach their children to cook. Family dinner. Blobs are social. Yeah, it looks kind of antisocial in the top left, right? But it looks like they're actually maybe social creatures, right? Sorry? They are what? Yeah, chef. Thank you. Excellent. Good. Okay, let me give you a third example, okay? But now I'm going to do something a little different. Remember, satisfiability solver gives you things that satisfy the formula. That's what you did, right? On the first slide, okay? Now I'm going to show you something that is not an instance of a blob dinner, okay? It is a non-instance. This is not a valid party. I have blob, parent off, and cooking. Now, what might you guess from this? Does this add any information to you now? Children can't cook alone. Why didn't you say that earlier? Because they weren't cooking alone, and also I didn't show you any non-instances, right? Like partly what negative instances do is they help us better understand the boundaries of a space, right? Yes? Oh, yeah, I'll fall at some point, and then you'll help me up, and it'll all be good. It'll wake them up when they start reading email. It'll wake them up by falling over. Thank you. Good, but no, thank you. I appreciate that. Yeah. Okay, good. So this presentation is entirely driven by reading the CogSci literature. There's an entire area of what is called contrasting cases, and there are multiple principles that contrasting cases suggest. The main thing is it helps to show a collection of things rather than a singleton of things at a time, and especially if they are carefully chosen to contrast in some way. But the other thing you get out of the literature is that sometimes it may be useful to get and show negative examples, which is super weird if you think about it as a mathematician or computer scientist doing SAT solving, because we're saying, give me a thing that is a SAT unsolver or non-solver or something like that. Explicitly show me things that are not instances of the formula, okay? And yet, you're gaining insight from looking at the negative instances, okay? So this is one kind of study you can do. We call this a 2 plus 1 minus because on each screen you see 3 things. 2 of them are positive instances. 1 of them is a non-instance, a negative instance, okay? And you can guess that there might be other configurations to try. We probably tried it, okay? And this is again a situation where we have multiple sample domains, multiple conditions, we use crowdsourcing, we use student subjects, a whole collection of subjects, to get at somewhat robust knowledge. And what we learned from this is actually that multiple instances are not always helpful, but negative instances seem to be, okay? And that's kind of weird if you think about it, right? There's a place where we want to construct non-instances from a SAT solver. And if you think about it, that's a really strange thing to do because there's an infinite number of non-instances, right? There's all kinds of garbage is not an instance of the specification. And so there's an interesting algorithmic question on how to construct non-instances that are somehow meaningful as opposed to garbage, right? And so this is a case where the CogSci tells us a thing to study, the studies confirm that this is useful, and then we can go back and ask, what is the algorithmics that lets us generate those and study that question in a loop, okay? So if you're curious, I can tell you we generate what we call near-miss instances, right? So you take an instance and you tweak it in a little way. You do it by modifying formulas. If you're curious, ask me about it later, and I'm happy to talk about the math behind it, okay? All right. So what is the take? Oh, and by the way, the other interesting thing we learned is there's actually one mode that is even more effective than what I showed you. Have you ever had the situation where you're trying to understand something and you take 2 things and you put them like side by side and you flip them quickly and you try to look at the difference between them, right? Or you might like put the 2 browser tabs, you go back and forth between the tabs or something like that. You flip back and forth quickly. You've had this experience, right? Sometimes kids' puzzles make you do this too, right? And that's what that situation is. You have 3 positive instances, but you can flip between a positive and negative by just clicking on a button, and it stays in place so you can see the differences. And that turned out to be the most effective mode of all of these. So, what are the takeaways from the second part of the talk? I'm going to claim that this is going to offend a whole bunch of people in the audience, but this is basically what we do as computer scientists, right? This is the wheel as designed by a computer scientist, right? Instead of trying to study the literature from other areas, instead of studying other domains, we sort of go off and invent a wheel. Say, yeah, good enough. It'll probably be good, right? But we'll make these grandiose claims. And what I would like us to think about is if we could incorporate more methods into our research, if we break down some of these walls between theory and software engineering, algorithms, cognitive science, and so on, bring these in, we actually get to richer points, richer solutions, better solutions, more interesting places in space. Okay? And our goal is ultimately, if it's to have a cognitive effect, in particular, there's a rich and relevant body of cognitive literature, just as there's a rich body of social literature if we want to have a sociological effect like in education and so on. Okay? All right, third part of the talk, which is how to show things. Okay? Once again, audience participation. I'm going to put up an instance, and you're going to tell me what part of computer science this comes from. All right? Yes? Ready? Okay. So, here's the instance. Does anyone need me to read out some of the text? Can you read the text well enough? Okay, so I've got philosopher, philosopher, fork, right philosopher, left philosopher, next, left fork, right philosopher, left fork. Operating systems. Why did you say operating systems? Dining philosophers, right? Okay, good. And now I'm going to show you another state, okay, in the dining philosopher's algorithm. Can you tell me where all the differences are? Can you see the differences? Can you point? Yeah, you're pointing. Pointing where? Up, down, left, right. Right here? Oh, sorry, I'm not here. Yeah, where? Yeah, right about there. Yep. Any other differences? Somewhere over there? Yeah. Good, 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 good. Okay. So you could imagine using this kind of thing to actually teach operating systems, right? To, you know, your textbook contains like a very static thing, doesn't let you experiment, doesn't let you try slight variations of dining philosophers. You could imagine giving this to students and having them try little variations and see for themselves how the algorithm works, right? Yes? Yes? Would you like to learn dining philosophers from these pictures? Really? No, not so much. Why not? Bit of a mess, right? Your brain's not going to process this. But isn't this how it's presented in your textbooks? Like this? No, how is it presented in textbooks? Yeah, everybody's drawing circles. You know, kind of like that, perhaps, right? And like that, right? So these are exactly the same states, exactly the same information. Is basically isomorphic. But what we've done is used a rendering that comes from the domain. And I think this one, I think we can agree, would actually be maybe a useful tool for a student to play with. Okay? All right, let me give you another domain, all right? So here's a picture. It says public key and ciphertext and yeah, some sort of RSA or some, it's a crypto protocol of some sort, right? I mean, it's obvious which crypto protocol, right, from the picture. Maybe not, but if I showed it like this, it's a lot clearer which protocol we're talking about. If you know crypto protocols, you'd recognize it. But it doesn't matter, right? What's going on here? The point is that various domains have spent a lot of time thinking about what notations make sense for them, right? They've evolved notations that make sense. You know, like some people like me call these Alice and Bob pictures, right? My message sequence charts, whatever you want to call them. The point is there's information conveyed here that's being lost over there, okay? So these pictures that I'm showing you are from our version of Alloy. It's a tool called Forge. And basically in Forge, you can do these custom visualizations, okay? It's actually not very much work, like 100, 200 lines of code will give you these custom visualizations for the most part, okay? But I want to point out that something's going on here that's more than just like pretty pictures, right? And to do that, I'm going to have to make you do some audience participation again, okay? So here's what's going to happen. I'm going to put some text on the board, on the screen, and you're going to tell me what color it is. Yes? We understand what we're doing? I want everybody to yell as quickly as possible, so you really have to put down your laptops at this moment, okay? I want everyone to yell. The moment you know the color, I want you to yell. Okay, you ready? 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 Okay. Too slow. Faster. Okay, what's going on? Okay, I played a classic trick on you. This is called a Stroop effect. Okay, and Stroop effect in psychology is basically, it measures the reaction time between congruent and incongruent stimuli. And what I just showed you, when I show you the text and the color in the same thing, that's a congruent stimulus. When I showed you in opposite ways, that's called an incongruent stimulus. And you saw for yourself what happens with incongruent stimuli. Okay? Now, Why am I showing you this? Here's why. Let's take one last domain, okay? And I want you to see, so let me read out the text. It says farmer, fox, eats, chicken, eats, grain. What does this sound like? Yeah, there's a class, these riddles, they're called river crossing problems, right? Like I have to move the farmer, but the farmer eats something, something, blah, 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 right? Okay, good. Okay, so here is another presentation of it, okay? And we can agree it's kind of prettier, right? It's a cute looking chicken there. We certainly wouldn't want it to be harmed, okay? And now here's another pair of states after a change of state in the system, okay? The point is not just that the bottom pictures are prettier and maybe, you know, like, oh, it's easier to tell which one's the chicken. The upper states, notice that they look isomorphic, right? Structurally, the fox and chicken are on the opposite sides the whole time, but they're on the same side of the picture, okay? And the farmer and the grain change sides, but they stay on the same side of the picture, right? Essentially, that picture is incongruent stimuli. It's a little bit like a Stroop effect on your brain being done by the tool, right? Now, the tool's not trying to go out of its way to mess with your brain. It's just like we have layout algorithms that try to do some things. In fact, this layout algorithm is actually trying to help you in some ways, and it's hurting you in other ways, right? So the broader point is not just, oh, we have cute, you know, visualizations in different domains. The broader point here is there are actually important things about domains that a generic visualizer is not going to understand, and that are very important for people to be able to understand what is going on, right? So not only have domains evolved metaphors, and sometimes we can even build sort of these epistemically closed systems for doing exploration of little domains, but also these spatial and temporal and other relations are critical for understanding the output that we see. And generic tools miss those, and so a large part of our effort in Forge is to make it as easy as possible to convey the spatiality and the temporality and other relations to the presentation system so that it can take those into account and use those when showing things to the user, right? So that we don't accidentally create Stroop effects on our users. Okay, good. So that's the third part, and now I'm going to tell you the fourth and last part. Okay, how do we describe systems? So I'm going to focus on a very particular part of system description, which is a thing called linear temporal logic. Okay? Now, linear temporal logic starts with propositional logic, which all of you know, and how do I know that you know it? Because you've all done quizzes for me. You've shown me that you're SAT solvers, right? You're in the flesh SAT solvers. Okay? So you all know propositional logic already. But now let's say what I want to say about a system is I want to say something like, you know, eventually I get a green traffic light, right? I'm looking at a traffic intersection. I want to talk about its properties. Or I never get the case that it's never the case that I get both a green and red at the same point, right? Like a safety property. Or I want to say something about like locks, right? That if you grab a lock, eventually you're going to release the lock. Or maybe, you know, if you're like my household, you write down, you know, your rules for your child, and you write down like no cookies until you're done with homework, right? So there are all sorts of domains where we want to express these things, and you notice that all the words that I've underlined are statements about time. Okay? So in linear temporal logic, what you do is you extend propositional logic with these temporal operators. Okay? And they, you know, if you look at like formal logic, they tend to use like single letter symbols. You can write them in single letters if you prefer, if it makes you feel like, you know, you're stronger or braver or something like that. But this is linear temporal logic. Okay? Now, this has been the source of a big battleground for many, many years. People who are old enough like me, and I think some others in the audience, will know that there were like these big battles, pitched battles about like CTL versus LTL and which temporal logic should be used. And people made decisions on this basis, right? So for example, here's Moshe Vardi saying, in contrast, the linear time framework is expressive and intuitive compared to CTL, okay? Or here's the temporal logic sugar, and it says we can easily and intuitively specify the designs. Now, you can guess that by this point, I'm looking at claims like this a little skeptical. In fact, the motivation for this work was LTL, which was designed for verification, has become very popular in robotic synthesis. Okay, so planning people have discovered LTL and used LTL in robot synthesis. And we went to a talk about robot synthesis LTL, and the speaker was from a robotics speaker, and so they did this very nice thing. They gave a brief tutorial about LTL at the beginning of the talk for everybody to make sure we're on the same page. And there was a mistake in the talk, and the speaker didn't catch it, and the audience didn't catch it, and made us think like, do people understand LTL? Let's go investigate a little bit. So what does it mean to understand LTL? Well, basically, you could break this down into two directions, right? I have something in LTL, and I want to translate to English. So if I read LTL, can I understand it in English properly, right? So I translate a formula into English. The other direction, of course, is English to LTL, right? And this is, in some sense, the thing we have to do on a daily basis. Well, but daily for my life, maybe not your life. But you want to write a spec, either for synthesizing a robot behavior or to verify a system. You have some natural language formulation in your head, and you have to accurately transcribe this into the logic. Okay? So that is on the syntactic side. There's a subtlety here, which is there's also a semantics. The LTL semantics is given in terms of these infinite word automata. And so there's another thing you can do, which is also see whether people understand the semantics, which is called in terms of traces. Okay? And we did this lots of different, multiple years, multiple audiences. We even got data. This was fun. We also got data from people who are actually researchers who use LTL. Okay? So that was a very interesting data set that's not always easy to get. And what's interesting is what we found, it didn't really make a difference whether you were a student learning LTL or a researcher using LTL, which might disturb you at what's about to come. As you can guess, by the fact I'm giving this talk, it was pretty disastrous. And I want to focus on one of the problems that we found. So this was an attempt to systematically describe the problems that we found across these audiences and across years. And I'll give you one example of this, which is what we call the exclusive view. Okay, so I'm going to say X until Y. And I'm going to propose two different meanings for it, and you're going to vote for me, okay? You're going to tell me which one you prefer, right? So I don't want people to feel embarrassed by raising hands, so the way we're going to vote is we're going to hum, okay? So IETF style. So can you all hum for a moment? Come on, everyone. Even the professor is allowed to hum. Okay, good. Okay, so you all know how to hum, okay? So here are two choices. One is X is true until time t. At time t, Y becomes true. The second interpretation is the same as before, but at time t, X becomes false. Okay? All right. So you get to vote. How many of you vote for 1 by humming? Not a lot of people. Okay. How many of you vote for 2? Were you all Americans? You don't vote? Ooh, yeah. Okay. All right. Okay, let's try it again. 1. Okay, and 2? Much stronger for 2. Okay, good. Now, how did you choose? I mean, I'm asking you to pick a semantics for a logic here. How did you choose? Probably use like an English sentence and translate it into your head and said like, which of these two behaviors do I get, right? And so let me give you an English sentence, all right? Here's a sentence. Robot's motor is on until the robot reaches its destination. Which semantics is this, 1 or 2? Which one would you want? You want 2? Why would you want 2? Because you want that, so you'd be very disappointed if the robot got there and kept running, right? You want the robot to shut off. Good? So there's a good intuitive reason for why we actually want 2. Okay? Any LTL people in the room? I know there's at least 1. What's the actual semantics? It's 1. Okay? But let me make you not feel too bad about it. Let me give you another sentence. Which semantics is that? It's not committing to eating a cookie, right? So it's not actually saying the moment I clean my room, I will eat cookies. So it's actually a little closer to 1, right? So you can start to see the kinds of issues you run into when you start to understand how people interpret logics, okay? And sort of a long story short, what we discovered is people actually generally did pretty well going from LTL to English. I showed you one of the main exceptions, okay? trace satisfaction, the semantic level was pretty bad. And English to LTL, which is the most important one, right? Like that's the one you engage in the most, like really bad, okay? Which is disturbing because that's the one we need the most. Okay? So what do we take away from this? First of all, there's all sorts of implications for the tools that we build, right? Because we build these tools assuming that people have perfectly stated their intent. But if people can't perfectly state their intent, maybe we should be adding more into our tool cycle to make sure that people's expressions are what they wanted to be. Okay? Secondly, we've created a bunch of valid instruments that would be useful for teaching. So if you teach LTL, get in touch with me. If you teach any logics at all like this, get in touch with me. I'd be happy to share our instruments. You can improve your students' learning of these language tools. But finally, I think maybe the most interesting thing to me is we have potentially better designs for these logics, but more importantly, we now have a methodology for how to go about designing a logic. So the next time you want to design a formal logic for verification, synthesis, something like that, instead of just writing these like bold statements about, oh, this will be more intuitive, this will be more clear, we can actually test these and then design something that we actually know is going to be and figure out how to like educate people to prevent them from falling into pitfalls. Okay? All right. So that's the end of the technical part of my talk. Basically, I showed you 4 things. What do we compute? Right? We have satisfiability in this particular case as an underlying algorithm. We tried to make richer and cleverer algorithms that were mathematically a lot of fun, but not so great for humans. There's a huge open area, but how do you design the algorithm that's actually going to get the best human consequences? Okay? The second is, what do we show? I showed you how there's a very rich literature in cognitive science and educational psychology that can help us here and help us build better things to show. Right? Specifically things like multiple instances and even more negative instances, which is sort of the antithesis of what a SAT solver normally generates. The third one is, how do we show it? And here I try to make a case for domain specialization, not only because experts recognize them and students need to learn them, but also because we want to avoid creating misconceptions in the minds of our users by not taking into account, for example, spatial and temporal relationships. And finally, I talked about how to describe systems. I gave a case study of LTL and showed how there's a lot for us to do in these things, these languages that we design, that we think are intuitive, that we believe are intuitive. There's a huge wide open space here that needs to be explored. Okay? There's a lot more here. One example is, how do we get people to appreciate the need for properties for formal verification? Another one is, there are rich type systems that are basically a form of human factor, a form of formal methods as well. How do we design these type systems? Also, how do we explain these advanced type systems? They're doing very sophisticated things in very interesting ways, and oftentimes they give us huge benefits like reducing, memory violations and therefore getting rid of segmentation faults and improving system security. But if you can't understand them, you can't use them. And how do we bring all these other tools we have to bear to do these? So this is the parts of my work that I'm not talking about, but I'd love to talk to people about more. Okay? So to wrap up, what I really hope I'm trying to make a case for is that we normally think of like algorithms as separate from software engineering, as separate from like education, as separate from all these other things. I want to claim they're not. There's this beautiful virtuous cycle we can get into. If we do it too late, it becomes vicious. But if we do it early, it's virtuous. And as all of these things can talk to one another, inform one another, we can actually get to a much richer style of algorithmics if we think of it as like cognitively justified algorithms rather than algorithms that we just dreamt up. Right? There are rich problems waiting out there. They're a little different from our current problems, but they're no less rich for that. In some sense, I feel like they're actually much more challenging. Okay? So I want to make a case for this way of thinking about the world. I've told you about Forge, so if you're interested in formal methods, if you're teaching formal methods, love to talk to you about the tool and talk about where we could go with this. And finally, there's my contact information. If you want to reach out, you're more than welcome to reach out. And that's the end of my talk. And Viraj, I think I am well under target, so I have time for questions. Sorry? There are no mics here, but I can repeat questions if people want to ask them. Yes? I'm sorry, I can repeat your question. Yeah. I'll repeat it, don't worry. Yeah. Go ahead, Yeah. I guess the mic's there now, so you can, I guess you should repeat the question. Yeah, sorry.
Okay, sorry. I'd like you to comment on a couple of things, which you've almost answered in one of your latter slides, but I'd still like you to comment. The first one is, the language is imprecise. If the language is imprecise, you're not going to get the right answer, which it seems to be here. The second one is, you don't have the acceptance criteria defined clearly, which means you're possibly going to get the wrong answer. The third one, the answer, or at least maybe you're hinting at an answer here, is using the correct methodology. And for Bob, I'm just going to say, the answer might lie in part in DevOps, but I want to see what your comment is on it.
Okay, I'm going to skip the third question because you've already got an answer for that, but I will talk about the first two. So the first part is about the imprecision of language. And I mean, you know, in some sense, the whole game of computer science is moving from the imprecise to the precise, right? This is the computer science problem at some level, if you will, right? So, and that's tied to your acceptance criteria too, because if I don't know exactly what I meant, then how do I even know whether I got there or not, right? And my response to that, so these are extremely great observations, and I would argue that one part of it is, this is why we have a variety of methods, right? We don't only have quantitative methods which are very good at measuring precise things, but we have qualitative methods which are very good at giving us insight into situations where we don't have proper precision, we don't have complete precision, we can't just compute a p-value and go home, right? And that gives us nuance into what are people thinking and how do we shape things in the direction they're thinking. But getting back to the precision question, in some sense the hope, and this is also not entirely accurate, the hope is that the user has something precise in their head, okay? But the reason I like these lightweight methods is that's not always true. If you go back to the very beginning of my talk, right, I said, show me some examples of binary trees without even a property, right? And you see this example, like, well, that's not a binary tree. Well, why not? Well, because I don't like that part of it. Well, you codified that. Then you see the next one is like, well, that's not a binary tree either, right? So we do this by induction, right? We're sort of in a Popperian universe. We do this by induction. We falsify things as we go along. And then we get to a point where we maybe, and this is where working with other people helps us because they come in and say, well, I don't think that's quite right. I prefer to think of it this way, right? So we have to go from the imprecise to the precise in steps. And we won't know exactly when we're there unless we have a very precise thing to begin with, which we sometimes do. We have mathematical objects, right? We have a spec of the Ethernet or specifications of these various things that we can use, and when we get those, are a crypto protocol, right? There is mathematics. Sometimes we have math, sometimes we have formalization, and sometimes we don't. But the other part of it is figuring out the misconceptions that people have and helping them with their misconceptions, right? There's an entire body of literature on this as well, on trying to figure out how to unearth misconceptions and how to correct them. And I prefer to think of it that way. So I said with the LTL part, we have to think about the tools we build. The tools assume you got it right. And instead, maybe we can say, here, you wrote down the specification. Let me show you some sample scenarios, right? You might say, well, that's not, no. And if I know the kinds of misconceptions you have, I can use the misconceptions to drive the sample scenarios that I show you, because I think it's quite likely you think those and those are wrong. And you might say, oh, that looks good. You're like, oh, that's not what you wrote at all, right? And so we have to use these kinds of inductive, human-driven processes to try to get closer to the truth. Is that a reasonable answer? Great, thank you. I think your mic's off, sir.
Hope you can hear me now. So, Sriram, in the dining philosopher's problem that you showed, the initial visualization was like a spaghetti graph, and your complaint was that there's no dinner table even in the picture. But if you are looking for reachability analysis, for example, then somebody would have preferred the first picture rather than the table. So it also depends on the ultimate goal that you have, right? So it's not that one visualization fits all. So somewhere you have to factor that in as to what is the ultimate purpose of this visualization.
That is a great point. So I'm going to push back a little bit in the following sense, okay? If you're doing a visualization, odds are you're trying to show something to a human. If I wanted to do reachability, the graph would just sit as a data structure internally, and I would just compute it and I'd be done, right? So now, it is the case that sometimes I want to show it to a user and say, try to trace through something. And I think that's why, we have an ancient principle from software engineering, right, which is the model view separation. And that's essentially what we're doing here, right? I've got a model of the dining philosophers, and I showed you one view. which is a default view. I showed you a second view. And again, if there's another language you want to speak, another visual language you want to speak, we should have tools that enable us to speak all these different visual languages. And in some sense, that is one of the driving forces behind Forge, this tool that I mentioned, is I don't want to pick for you, but I think many domains tend to have sort of a canonical visual language, right? In fact, many of the things that our students have built is also like, games, right? Like, baseball, which is like this inferior form of cricket that they play in the US, right? Sorry. So, baseball has this canonical presentation of diamonds. Or maybe you're doing a card game and then we have this canonical visualization in terms of a deck, right? So there are those, but again, I don't want to be judgmental. And again, in some sense, once you study that visualization, I find it's not very good for the purposes you had in mind. So very much an open-ended question. Okay? Thank you.
Hi,
Just one more. I cut my talk short.
Hi, Sriram. So that's a wonderful talk. Yeah, I can use many of the insights in my teaching as well. So just one thing, like you told that there's some insights about this learning itself from educational psychology and all. Similarly, like for example, if you see machine learning, well, how machine learns, for example, the technique that you talked about, contrastive learning. It's a well-known technique in machine learning, right? So can we also take some techniques like how the machine learns? If we understand that, can we actually use those insights in this? But one can argue that actually machine learning is borrowing from how human learns and all.
I think it's very much in that direction. I don't know enough to know the answer. I mean, at a generic level, I'll say yes, of course. We should certainly try to borrow techniques in any direction we can. We should I'm willing to try almost any reasonable hypothesis. So far, my sense is a lot of the machine learning ideas have really been like take a human learning insight.
Yeah, that's I still want to hear to you.
Yeah, but yeah, I think it's perfectly reasonable. And if there's a radical new way that machines learn that we think makes at least some sense of the cognitive architecture, it certainly makes sense to try that. Yeah. Thank you. Last question. Make it quick. Otherwise, he's going to yell at me.
Yeah. So, a lot of this really boils down to, I mean, there's a certain vocabulary in which we understand something best, and what we're trying to do is in different vocabulary, and we're trying to do this vocabulary translation, right? Large language models seem to be doing quite well for at least some aspects of this, particularly for teaching logic, for making real engineers try to use logic for specifying. I mean, do you think that there's room there?
No, I think, look, we can't talk about computer science in 2024 without LLMs coming in, right? It's like it's a Godwin's law kind of thing for CS. So yes, the short answer is, of course, currently I've tried these things. They're not very good for now. But I think, again, we should go back to your original question. We're trying to go from the informal to the formal, right? And so I think it makes absolute sense to think about tools like LLMs being in the middle. For example, you start by writing your property in English, feeding it to an LLM, getting it to generate the logic, and then working within the logic to try to tweak it. But I think the trick is figuring out what are the right tools to get into that feedback loop after you've obtained your first LTL formula, whether it came from an LLM or human or something else, right? To me, that's the interesting question. But if there's a way we can accelerate getting into that loop, right, to get from that informal LLMs or whatever, absolutely. I mean, people have tried to do this with like drop-down menus and various other things as well in the past. I'm open to any of those. The intellectually interesting questions to me that sit at the intersection of cognition and mathematics is once we have that first thing, what does that loop look like? So, okay, and now you really are kicking me off. Thank you very much.
So at ACM India, we thank our speakers in this way. We plant a tree in your name. We have a tie-up with an organization called 14 Trees. I'm going to invite Professor Meenakshi D'Souza to hand over your certificate, which has a QR code so that you can watch your tree grow. Yeah? Thank you so much.
So it's not yet lunchtime, and The carefully planned annual event has ACM laureates giving talks here, and ACM India has the most coveted set of awards. And the awardees have already started giving talks at various venues. And we have the award ceremony now, sandwiched between the talks. And it's a two-part ceremony. And I invite Hemant Pandey, the Executive Director of ACM India, to walk us through the ceremony.
The Sriram will have the collar mic. Good afternoon, everybody. It's time for celebration. It's my honor to host this particular award ceremony of ACM India today. Recognition of contributions has happened. The awards have been declared. Now, today what we are going to do, and as Meenakshi said, before lunch and after lunch, okay? Because lunchtime is sacrificed. So we are going to do that celebration, celebrate the achievements. We're going to do that now. Okay? And I'm Hemant Pandey. It's my pleasure to be doing this. First, we want to talk about students' contribution and form of student chapters. You know that in ACM India, about 60% of population of members is that of students. And those students are often represented by the student chapter. And I think, if I'm not wrong, we have the highest density of student chapters in the India region. Okay? So it's natural that this is a very thriving part of our award function. So there is something that the winners and even the jury didn't know about, and it got done yesterday. That we have Walmart Global Tech agreeing to sponsor these awards, and that's more than double the previous award amounts. So I think let's give Walmart Global Tech a big hand. As you can see, there are multiple categories, and we mirror them on the way chapter awards are given at ACM level. So these are the categories, and these are the new amounts now, or prize amounts. But what I'm going to do is I'm going to let Vinit Kapoor, he's my ex-colleague of many, many years from Professor Joseph. So I'm going to invite him on the stage with the microphone that you would have it there. It's here. Vinit, you can use this. So he represents the award jury who have done the hard work of picking out from multiple nominations. And I'm going to hand over to him to talk about the process.
Thanks, Hemant. First of all, good afternoon, everyone. It's my pleasure and honor to be here to represent the jury for these awards. To start with, let me give a brief introduction about the awards, like Hemant talked about it. So these are 6 different categories, and these are yearly awards which are given to the ACM student chapters. And to give a brief about the winner selection process that we followed. Now we have received around 32 nominations from 32 different student chapters this time in different categories. The jury consisted of 4 people in this time. It's Mr. Satish Babu, who heads the in-app Infotech from Kerala. Then we have Mr. Bipin Mehta from Ahmedabad. We have Mini Ulnath from QSAT Kerala, and myself from Vinit Kapoor from Persistent Systems Nagpur. Now, to select the winners, all jury members independently evaluated these nominations that we received, and then we combined these evaluations to arrive at the winners for each of these categories. So some key considerations that were given for each of these awards, I'll just give a brief about it. For example, in the website award, we gave importance to the user friendliness of the website, innovation in designing the website, and how much updated the website is kept, like for different activities, different achievements they have got, and all this information. Then outstanding chapter activities, like chapters do a lot of activities, but how much relevant they were from a perspective of the goal of ACM, basically to advance the computing knowledge and other things. Also the extent of involvement of the students in the activities. Then outstanding community service, this was a bit different. So here we gave importance to addressing various society-related concerns, for example, cybersecurity frauds. So how much chapters are involving the society, spreading the knowledge about cybersecurity frauds, how they should be handled, and other aspects associated with it. Then recruitment program award. This was majorly for the chapters who were who are the ones who added various students and members over last 1 year as compared to what they were at the start of the year. Then emerging chapter, these are the chapters who are recently formed, recently established around 4 years back or so, and they are doing well. So these were the chapters who were considered for this award. Then outstanding chapter award was the one where performance on all these categories were considered, and then jury members gave their view as to who would be the outstanding chapter award. Now with this background, let me announce the award winners and request them to please come onto the stage. And also I request every one of you to please congratulate them by giving a round of applause. So we have one faculty sponsor and around 2 students representatives from each of the chapters here. To get started, first is Outstanding Chapter Website Award. This goes to Manipal University, Jaipur, ACM Special Interest Group on Embedded Systems Student Chapter. Request please representatives to come onto the stage. Okay, while they come onto the stage, I'll go ahead in the interest of time and announce others so that they can also start coming up. Outstanding chapter activities. This goes to Pimpri Chinchwad College of Engineering, ACM Student Chapter from Pune. Third one, outstanding community service. This goes to All India Shri Shivaji Memorial Societies, Institute of Information Technology, ACM Student Chapter, Pune. Fourth one, outstanding recruitment award, program award. This goes to Kare ACM Student Chapter, Madurai. Fifth one, emerging chapter. It's a Vellore Institute of Technology, ACM Women's Student Chapter, Chennai. And the important and the fifth one, outstanding chapter, goes to University of Petroleum and Energy Studies, UPES, ACM Women's Student Chapter, Dehradun.
Come forward. Please come forward. And now what I'm going to do is to request Vinit to actually hand them their awards, the plaque. I hope they are standing in that sequence. From there, I think. Oh, website award. Oh. to it there. Finally, the overall outstanding chapter. Thank you everybody. Congratulations, and I don't think this will be over until we acknowledge the hard work put in by the jury doing this. So in appreciation of that, it's my honor to present you another jury members, the tree that we have planted at 14th. Thank you. Thank you very much. Another one, please. Thank you. Thank you, everybody. And now it's my pleasure to invite Supratik Chakraborty, Vice President of ACM India, as well as he's been associated with the Doctoral Dissertation Award probably since its inception. So, yeah. So Rajiv Allur, who's the chair for the Doctoral Dissertation Award jury, he couldn't be here from the US, and all jury members are from outside India for a very good reason, so that there is no conflict of interest. So Supratik is going to fill in for Rajiv. And TCS Research has been the founding sponsor for the doctoral dissertation in ACM India Doctoral Dissertation Award. And I'm going to invite Sadhana Rana, who's representing TCS Research, to come on the stage, please. There she is. So, come. So Supratik, you want to tell us about the process that was followed and how you converged on the two winners that we have?
Okay, so yeah, thanks, Hemant. So ACM, the ACM India Doctoral Dissertation Award, this has been around since it was established in 2011. The first edition of the award was given in 2012, and it recognizes the best doctoral dissertation from degree awarding institutions in India in topics related to computer science and engineering for each academic year. And I think over the years it has grown to a stature where every doctoral student in computer science in India really, strives for having their name shown on this podium like we have today. So this prize, this award is accompanied by a prize of Indian rupees 2 lakh, which is 200,000. And there is an honorable mention which is given only if there is a close tie between the first and second positions. And the honorable mention goes with a prize of rupees 1 lakh or 100,000. And the dissertations are published in the ACM Digital Library. And Tata Consultancy Services is the founding sponsor of the ACM India Doctoral Dissertation Award, and have continued to sponsor this. Thank you very much. So as far as this year's awards are concerned, we received 19 submissions this year. Professor Rajiv Allur from the University of Pennsylvania was the jury chair, and there were 12 jury members, eminent computer scientists from different parts of the world, who were part of the jury. And each submission was reviewed by at least 2 committee members, and based on the ratings given by them, 5 submissions were shortlisted for further discussion. And these spanned different areas like theory, computer vision, natural language processing, and operating systems. So we had contributions across different sub-areas in computer science. And finally, based on a lot of discussions and rounds of voting, the winners were chosen as, the winner of the ACM India Doctoral Dissertation Award 2023 is Pranjal Datta. Please give him a loud hand. For his thesis on A Tale of Hardness, De-randomization and Debordering in Complexity Theory. He finishes, hey Pranjal, please come up. He did his PhD from the Chennai Mathematical Institute under the supervision of Professor Nitin Saxena. So congratulations, Pranjal. And
yeah, you can do that, both of you. Pranjal's parents are here too. Pranjal, you want to say a few words?
So thanks everyone for coming. So I actually wrote a note because I have to thank at least a couple of people. So first of all, thanks to ACM India, the committee members, and for choosing my thesis as the winner. It's a great pleasure to be here among all the great researchers, students, and so on. Thanks to Hemanji, Avijatji, and Nizar for hosting such a beautiful event. Yeah, so as I said, I have to thank a couple of people here. First of all, thanks to my advisor, Professor Nitin Saxena, for his constant and unwavering support throughout my master's and PhD, and both in academic and also like mental support, because 50% of my PhD was done during COVID, where I was stuck at home. So that mental support was very important. Thanks to my parents, because they are, I think, 1, 2, 3, 4, 5th row, they are sitting there. So thanks them for coming, yeah, for their unending and constant support. Thanks to my sister and my dog, who could not join us because somebody had to take care of the dog. But thanks to them, because they also were a part of my PhD journey, because as I said, 50% of the PhD work was done at home. So thanks to them. Thanks to CMI, where I basically studied undergrad, master's, and PhD, especially KV, Madhavan, and other professors for teaching and giving all the flexibility so that I could roam around and do good research. Thanks to Google for their PhD fellowship from 2018 to 2022. And thanks to all the collaborators for, I mean, it has been a great journey for learning and so on. And finally, I see some student faces, so I just want to give a quick 10 seconds of things. So there was one point of time when I was thinking of giving up my PhD, and I had a long discussion with my advisor, because I was so frustrated during PhD that nothing was working, and then I had a long chat and so on, and eventually Nitin convinced me that no, I mean, please continue, take whatever time you need, but you should continue, and here I am. So yeah, so don't give up, try whatever you want, and it will lead to something nice, I'm pretty sure. And lastly, this award gives me an immense opportunity and encouragement to do good research, and hopefully I'll be able to continue to good research. So thank you, everyone.
Thank you. And to go with the award, here is again a tree planted in you. Thank you.
Thanks to TCS also for the money.
So do we have Jogendra on the call?
Yeah, so the honorable mention, which is a very close tie with the winner, goes to Jogendranath Kundu for, can we change the slide? Jogendranath Kundu's. Okay. And his dissertation was on self-supervised domain adaptation framework for computer vision tasks. And he completed his PhD from the Indian Institute of Science, Bangalore, under the supervision of Professor Venkatesh Babu Radhakrishnan. And unfortunately, he could not join us here today, so he is joining us. He could not join in person, so he's joining us online. Jogendra, are you there?
Yeah, yes.
Okay.
Yeah, hello everyone. So I'd like to express my sincere gratitude to ACM India and the selection committee and everyone involved in the process. The recognition is not just a testament of my work, but also reflection of collective efforts of many individuals who have supported me throughout my PhD journey. So first and foremost, I'd like to thank my parents for their unconditional love, encouragement, and support throughout my PhD. This award is as much as theirs as mine, as I dedicate it to them. Yeah, so I'm deeply indebted to my advisor, Professor Venkatesh Babu, whose invaluable guidance has been instrumental. His faith in me and my research efforts has substantially helped me grow as a researcher. The thesis work is a collaborative effort, and I'm grateful to all the project assistants, interns, and collaborators who have helped me with the research projects. The dedication, initiative, and hard work was critical to the success of several of the initiatives and projects that I undertook during my PhD. Yeah, so I'd like to thank Indian Institute of Science and TCS for the award money. I'd like to dedicate this award to every aspiring PhD researchers who is working tirelessly towards their goals. May we continue to push the boundaries of knowledge and technology, and may our work contribute to be used for betterment of the society. Thank you once again for the honor.
Thank you, Jogendra, and congratulations.
Thank you very much.
And we will make sure that the plaque, the certificate, and the certificate for the tree which is planted in your name, they reach.
Yeah, thank you so much. Yeah.
And the money. Thank you very much.
Yeah.
Oh, the reason I didn't say it, thanks, is that money has already reached.
Okay. So, yeah, thanks once again to TCS for being the founding sponsor and continuing to support.
And in appreciation of that, we have a tree has been planted in the name of TCS, well, representing TCS research. Thank you.
Thank you.
So while we move these slides, correct, we are at that place now. So at this juncture, we are taking the change of gears, and I would like to invite Vicky Hansen, who's the CEO of ACM, to represent ACM, because it's an ACM award. It's called the Gordon Bell Prize for Outstanding Contributions in HPC. And it's the same Gordon Bell mentioned by Bob in the context of 3Com. And I believe the award is sponsored by Gordon Bell himself. Oops. It's there on the slide. All right. So I invite Vicky to say a few things about this award.
That's my thing. Hi. Thanks very much for having me here. Is this on? Are you hearing me? A little closer? Okay. Now can you hear me? Okay. So yes, I've been asked to announce the recipients of the Gordon Bell Prize. This prize is awarded each year to recognize outstanding achievement in high performance computing. Sorry, I'm in human computer interaction. In high performance computing. $10,000 US is the financial support for this prize, and it is provided by Gordon Bell himself, who is a pioneer in high performance computing and parallel computing. The recipients for this award are chosen each year by a global group from the ACM Awards Committee. For 2023, an 8-member team from India and from America were chosen to receive this award. I'll read the name of the paper that got them the award. Large-scale materials modeling at quantum accuracy, ab initio simulations of quasi-crystals interacting, extended defects in metal alloys. Right? So I'm pleased that there are 2 recipients of the award here today from the Indian Institute of Science, Bangalore. The first is Fani Motampari. And the second, Gaurav Pranagrathy.
Would you like to say something?
It has been, I feel very honored and excited to actually represent Indians of Science and my Department of Computational Data Sciences at IISc to represent at the global stage of work which we are a part of, the Gordon Bell Prize 2023, and along with my PhD student, Gaurav Pranagrathy. So this award is a testimony of almost a decade of effort, starting from my PhD at the University of Michigan, and also the work which involved my research group at IISc Bangalore with my PhD students. And I thank my PhD advisor, Professor Vikram Gavini, other mentors and collaborators without whose support this would not have been possible. And I would also thank ACM India for taking this opportunity and for kind of recognizing the contributions from India as well. And I would like to thank my parents without whose support this would not have been possible, and what you can do based on what your dreams are. Thank you.
Would you like to say something?
Since it's lunchtime, I'll just keep it short. Already my advisor has thanked a lot of people. I'll just thank my advisor. Thank you, sir, for all your support. And thank you, the sponsors. Thank you for making it happen in Bhubaneswar, because this is my hometown, and receiving this award here is such an honor. Yeah. So thank you, everyone.
So the award has already been given in the HPC conference. So what we have is that we will give you the 43 certificates and fun. Thank you. Thanks. And Vicky, in appreciation of you, I'm going to call you again on the stage after lunch. We are on schedule right now, but while you're here, in appreciation of you being here, here is a tree that actually we went to 14 trees 2 weeks ago, and some of us we planted all these trees. Oh. So this dashboard will tell you about this tree. I've been told that lunch should not be delayed. We are on schedule. So this is the first half. Lunch is delayed by 15 minutes. Vicky, will you please come back? Yeah, we'll do the, I hope Vijay is here. Yeah. You mentioned photograph with the winners? Okay. So we'll do a group photo. Okay. So instead of continuing the awards, do you want to do a group photo? That might take some happy chaos, as we say. That will take us until, is that okay?
Okay,
Yeah.
I will sit down now.
And so will I. All right, so by popular demand, we're going to do a group photo because some people might leave. So we will do another group photo at the end of the event. So please, do we all come on the stage? Or, hey, this thing, get the main slide. Huh?
Yeah, on popular demand, everybody please come for the photo moment. So a bunch of academicians and
Yeah.
researchers don't get free lunch all the time. We do
You
wait.
want it switched off. All right, switch off the screen. Yeah.
Requesting all the participants to please come on stage.
The stage has been stress tested, I think. This also, our director for photographs has said the screen should be blank. Yeah. PK. Yeah, yeah. Switch this off. wonderful. Tell me about it. Sir, be here. Sir. I planted your tree personally. How do you think I planted your tree? Yes, so indigenous only. Indigenous to that region.
Yeah, it could like, yeah, sort of maybe the Shisha and all are Western Ghat.
There is mango, chinchon, tamarind, moha, and of course there is binomial scientific name there. Yeah. Okay.
Actually, we want to take a photo of the garden.
Yes, yes. We'll do. Oh, you were doing that already.
So food is here. If you want to, you can start walking.
Yours is after the awards or before the awards?
Vinit? Vinit. Okay. Now TCS Research want their picture. So I'll do that now. Ah, this one. Okay, come. Not only your if it does not work, what is the backup? So you were talking about chapters. Yes, you told me. Yes. Just in case that does not. So which chapter? Which one? Okay. Oh, this is your the overall winners. Okay. Outstanding website award. Community. Come. Yeah, let's do this quickly. I'll work with sponsor. And person. Okay. Next chapter. PCCOE. No, they were website. Website. Okay, turn for the website award. Yeah, MJ, quickly. Everybody join Zoom again. No. Okay. Vicky, Lena. Okay, any other farmaish? PCCOE, next. Because we need to start the next section. PCCOE.
And I took my trade. He was fabulous. Best present ever. Yes. But it's in my hotel. Sorry.
No. Those who are visiting
I can get a taxi home and head
So I'll just say that we don't want to break it.
Well, it was really, really fantastic. Best gift ever.
Thank
Really
you.
was. Really,
Thank you.
really was.
Thank you. This is my wife's idea.
Oh, that's your wife.
Yeah.
She's obviously the brains
So,
of the family.
14, thank you. 14 trees is obviously prohibited. But replacing the physical gift with tree planted in the name of those who are contributing, rather than giving them a physical gift. That is
Brilliant. It's absolutely brilliant. Yeah. Everybody has said that the best gift. Everybody.
We got mail from Alan during award dinner
Oh, yes.
saying that I have received many awards. It is the most distinctive award I have received.
There you go. Very much so.
अरे अभिजात तुझ्याशी तुला शोधा. ऐकलं चलो. Lunch is ready. We need to come back by 2 o'clock, right? घ्यायचं का एक आपल्या तिघांचा घ्यायचं का
कोई बात नहीं तो कीजिए तू इधर आ
This is right, sir. Yes.
What's a minute? Where is Srivastava? Okay, my mic.
Start from here. But not one, just out. You want to use your laptop because of the high res.
So,
You are
while
starting
you
already?
test it out, we'll fill up the galleries.
I think it's let's do it after.
There is a break. But there is a break between your talk.
Because I think starting then we will.
The simplest will be here.
Yeah.
And maybe even far, so that when you give, immediately.
Right, right.
So let's do that.
No, no, we'll do that.
Have the certificates here?
Yeah.
Yeah, there is also
but it's not, control is not here, right? Yeah, I have it. Back. Yeah. This celebration continues. So welcome back to ACM India Award Ceremony to 10. All right. So again, just to continue on the momentum, and since this is an ACM recognition, I'm going to invite Vicky Hansen, ACM CEO, again on the stage to tell us about ACM Fellow Awards recognition and more.
Hello again. Good to see you. So ACM's most prestigious member grade recognizes the top 1% of ACM members for their outstanding accomplishments, both in computing and in their service to the ACM community. These people are recognized because peers in their community nominate them. They know they're doing outstanding work, and they nominate them to the ACM Awards Committee. I'd like to encourage you, if you know of someone who's doing exceptional work, give their name to Hemant here, who's working on behalf of the ACM India Council to get more people in India recognized for ACM Fellows and Distinguished Members both. Okay. All right, so in terms of fellows, this year ACM honored Manik Varma as an ACM Fellow. Unfortunately, yeah.
Give him a big hand. Yeah.
I was going to ask you to join me in thanking him, even though he's not able to be here today. The Distinguished Member grade recognizes the top 10% of ACM members for their accomplishments and service to the ACM community. And we're pleased that one person from India was recognized this year for his efforts. And I'd like to call Vijay Arya up to the stage, get his award. Congratulations.
So again, the award has been given out or will be given out from ACM, but
right. ACM has an annual award ceremony in June every year, and they, at least the fellows, were recognized in person at the awards banquet in June.
So can I request you to hand his booking? Again, we went and planted it. So. Vijay, would you like to say a few words?
Can you hear me? Okay. First of all, thank you to ACM for for this recognition. Really appreciate it. And thanks to my nominator, my referees, and a huge thanks to ACM India for inviting me here to receive this award. So really appreciate it. I want to thank my collaborators, co-authors, mentors, mentees, and colleagues and faculty members at my former and current institutions, IIT Delhi, INRIA, National ICT Australia, IBM Research. I feel pretty lucky and blessed that I got an opportunity to work with such good people and learn from them. And this award is actually recognition of all the joint work that we have done together. I also want to congratulate all the ACM awardees at this event and all the ACM distinguished member awardees worldwide this year. I look up to a lot of you folks, and your technical work has inspired me, countless times, and it kind of, motivates me to work on a lot of interesting problems. So just having my name alongside, all of the other ACM distinguished members is a big recognition and honor for me. So thanks a lot for that. And lastly, by a lucky coincidence, Feb 10th, today is also my marriage anniversary. So, so my spouse is here, and okay, she's here, yeah. And this feels like an anniversary gift. So a big thanks to ACM for that. So thank you very much.
Thank you. So, if I can request you to stay on the stage for some. Since this is again event, it's a celebration event. So what we thought is that the ACM global officers, representatives who are here, who have taken the time to travel long distance to be here with us, we should at least invite them on the stage, give them a big hand and a big thank you. So Vicky is already on the stage. I'm going to ask Yanis, president of ACM. He's been on the stage before, but please come. Pat Ryan, ACM COO, as well as Ruth chairperson for ACMW. So as you know, let's come to the, and what I would like to do is invite ACM India President Venkatesh Raman to come and do the honors of giving one tree certificate which hasn't been handed yet. Because other occasions, they all got the tree has been planted, you received the certificate as well. And we decided not to print multiple certificates for the tree to save trees. So that's why the only one left now is for Pat. We can plant multiple trees is a suggestion. We will do that. But as Yanis said, some of the people have had multiple trees planted in their day. So we are picking up occasions to plant trees. And the goal is, as probably Praveen will mention it later. Should I mention it now, Praveen? Yeah, because we are talking, I think he said yes, right? Yeah, he said yes. So the simple back of the envelope calculation for 14 trees is that the carbon dioxide that one exhales in an average lifespan requires 14 trees to neutralize it. So to redeem our presence on the planet, back of the envelope calculation requires 14 trees. So having multiple trees, at least the goal is 14 trees in our name, perhaps. So that's the logic. So some of you have had multiple trees, and we will reach it. We'll reach 14. Thank you very much.
I just wanted to quickly say that I'm thrilled that you can follow the growth of the trees, because I have given trees to people in the past and they always said, "Where's my tree?" and I can't find it. So this is great.
All credit to Praveen and team. The QR code lets you follow the growth.
It's great. Thank you.
So at this stage, we are moving on to another ACM India award, and I would like to ask Professor Balakrishnan Bala to come on the stage as the chair for the jury selection committee for OCCE, which is Outstanding Contribution to Computing Education Award. Again, these awards were instituted 4 years ago. We have had a wonderful track record. And from inception, Microsoft Research has been the sponsor, the general sponsor of this award. So on behalf of Microsoft Research, can I invite Srivatsan on the stage as well? So Bala, if you could tell us about how you arrived at the award.
So, again, we have an international jury for this. So this particular year, we had jury members, which has Professor Susan Rogers, Professor Sartaj Sahani, Professor P.P. Chakravarti, and Dr. Manish Gupta of Google Research, and along with myself. So we received nominations, and of course, because it's outstanding contributions to computing education, so we are looking at various factors, so in which it could include not just things like writing textbooks, writing software, which are used by large number of students, and these days also in terms of video lectures and so on. The overall contributions that come from, and we are looking at a stage in life, so the maximum age for this award is 55 years. So it's a little later, but not still it's not a lifetime. So we still expect that they will continue to contribute to computing education. And in a country like ours, where there is a huge number of students who are actually into computer science, and we have, in terms of instructors, we still are in a big challenging position in terms of quality instruction. So all these contributions are actually extremely important to the growth of computer science in India. And so for the last 4 years, so this is the 4th year we are giving this award, and we're getting excellent nominations, but we would like this word to spread. And those of you who are teachers here, or those of you who are contributing to computing education in any manner, I request them to aspire for this award. It's very prestigious as well as very, in terms of the society, very high impactful award.
And did you announce?
No,
okay.
Okay, this year the award goes to Professor Sudeep Mishra of IIT Kharagpur.
So Sudeep, again, educator par excellence.
Yes, I know. I think you can share his experience.
Yes. And can I request you to present him with the award helped by Srivatsan? Sudeep, you want to say something?
Yeah, so thank you so much, ACM India, and for selecting me for this particular award. And I'm also very much grateful to Microsoft Research for sponsoring this award. There are a lot of acknowledgements that I have, but in the interest of time, I would just like to mention a couple of them. So I would like to, first of all, thank my employer, IIT Kharagpur, for giving me the platform to do whatever I wanted in terms of my research and teaching career. I am particularly indebted to my family, my parents, my spouse, my children, and my siblings. My father is already here, present over here. So I am very much thankful to them for giving me all the support. Yeah, sure. So thank you so much, Hemant, for the suggestion. I would request my father if he can come to the stage. It would be an honor for me.
Sudeep wanted to share it with us.
So incidentally, my father, he was a professor of mathematics at IIT Kharagpur presently he is retired in terms of occupation, but at the same time, he keeps himself busy. He still has PhD students and research papers. He writes single-authored papers himself, so he still keeps himself busy.
Yes,
Yeah, so during his time, he received the INAE Outstanding Teachers Award, which is very similar. So thank you to ACM once again for giving this opportunity to, both of us being recognized over here. So thanks a lot. So I also hope, just one last parting sentence. So I also hope that this award will help me to feel, it has already encouraged me. So I hope that with more thrust, renewed thrust, I would be able to carry on with more educational activities and research activities in the area of computer science in general. Thank you.
So on behalf of ACM India,
I heard from his father that he received the teaching award from INAE. So we had this talk yesterday on genomics, so we had to do maybe some gene analysis.
So on behalf of ACM India, we would like to give each one a token of appreciation. So would you be? Oh, I think they want us to come on the center of the stage. Sarah, for in appreciation of the sponsorship from Microsoft, Srivatsan. And again, for outstanding contribution as selection committee chair, it's my honor to present you. Thank you. And now it's my pleasure to invite Professor Sandhya Dwarkadas, who's the selection committee chair for Outstanding Contributions in Computing by a Woman Award. Sandhya is, as we call, HOD, head of the department at Computer Science Department at University of Virginia, herself ACM fellow, and I'll thank you for, she's been involved from the very beginning with the selection committee, and now she's the chair. I will, and I'll let her talk to us about it.
It's my privilege to chair the committee for the last couple of years, and can everybody hear me? And as Hemant mentioned, I've been invited by Hemant and the awards committee to be part of this awards committee. It's a privilege to be part of this awards committee for the last 4 years. So the award itself, it doesn't say that there, but if you look at it on the website, it says fundamental, innovative, impactful contributions to the computing field while primarily working in India. Keep in mind also, this is while also paying it forward. And by paying it forward, fostering a diverse and inclusive computing community so that all ideas thrive. And so our committee has been a 7 strong, roughly. It's an international committee. The current members are Ranjita Bhagwan and Gargi Dasputta, who are both previous award recipients. Venkatesh Kamath, who's here in the audience. Shweta Patel, Rajiv Rastogi, Barbara Ryder, and myself. And so, as such, what the committee did was to look at both aspects, as I said, mentioning focusing on looking at, of course, impact in terms of whether it's industrial, societal, educational, or academic, as well as research impact. So impact could be much broader than just academic publications. And so looking at the impact of the individual and the trajectory of the individual going forward, and also looking at what they've done to mentor the next generation and in terms of their outreach activities as well. It was a humbling, it's always been a humbling experience because there are so many people doing such excellent work. And the committee had the difficult task of selecting among really 8 really outstanding nominations. And so the winner this year is
Drum roll.
Nutan Lemaye. And Nutan,
And as we call Nutan on the stage, you notice that the award has been sponsored since its inception by Google. Now, nobody from Google could be here to represent them, so we talked together, Manish, Gupta, and hopefully as a surprise to Nutan, we said somebody else who's had a hand in having her this award, Meena, her PhD advisor, she's here, so we would like to invite her on the stage.
but before we do that, I'll say that Nutan has had tremendous impactful contributions in algebraic computational complexity, and has also been a role model in terms of all her activity, outreach activity, through ACM India and within IIT Bombay, where she most recently was. So congratulations.
Would you like to present her the award? Meena, you can lend a hand. And again, in appreciation of the contribution on behalf of ACM India, Sandhya from me. Yeah. And again, I think you can do the honors of giving the key certificate to Nutan and Meena. You have to, and to me. No, there is a tree for you. We went and planted one. Yes. Nutan, would you like to say? Sure.
Hello, everyone. Thank you for coming here, and thank you for your encouragement. I'm really delighted and honored to receive this award. The award gives me a reason to reflect on my research so far, and it's been very fulfilling, to be honest. And it also gives me motivation to continue pursuing ambitious research in the future. I'm thankful to IIT Bombay, and especially the Computer Science and Engineering Department for supporting me throughout and providing an ideal work environment. I would also like to thank all the women role models, without whom I would not have found the courage to make unconventional life choices and academic choices. Finally, I would like to thank my family and friends for their unconditional support and unconditional love throughout. And this also includes my academic family. Thank you, everyone, once again.
Thank you very much. We are not going to let Nutan go just yet. Can we fix that? Yes. So, and while we do that, now we come to the next and final award. I think the battery low has done something. now we come to the final ACM India Award, the Early Career Research Award. The reason, Nutan, we invited her to come over here is that Sunita Saravagi is the chair of the selection committee. She could not be here today. She has had a lot of travel. She's traveling right now. But we figured who better than Nutan, because she was part of the selection committee herself. So Nutan is here, and this award is has been sponsored by Persistent Foundation. So I would like to invite Sonali and Anand Deshpande on the stage. Sonali is the CEO of Persistent Foundation, and Anand is the director. So Nutan, you want to talk about the selection process?
Yeah, definitely. The Early Career Research Award were first presented in 2020. The award recognizes individuals in early stages of their career who have made fundamental, innovative, and impactful contributions to computing field while primarily working in India. I am one of the members of the jury. It was an honor to serve on this jury with prestigious members who I would like to list now. Amar L. Abadi, University of California, Santa Barbara; Naveen Garg from IIT Delhi; Y. Narhari from IISc Bangalore; Venkat Padmanabhan from Microsoft Research India; Sunita Saravagi, who was the chair of the committee from IIT Bombay; and Sudarshan from IIT Bombay as well. We had around 9 nominations in total. We had many discussions over a period of around 3 weeks to highlight and debate various aspects of these nominations. At the end of this, we shortlisted top 3 candidates. All these were excellent. We finally met online to finalize our decision. The winner of this year's ACM India Early Research Career Award is Dr. Siddharth Burman from IISc Bangalore. Siddharth has done impactful and fundamental research. He has created a large research group and thriving research group in IISc. Siddharth has been active in and contributing to the CS community in India. Congratulations, Siddharth, for this richly deserved award.
Yes. For Sonali as well as Anand, thank you for being generous sponsors. And let's hear from Siddharth.
Right. So thank you ACM, thank you ACM India, and in particular, thank you Persistent Foundation for their generosity and the numerous socially engaging activities that they are involved in. I would just like to express my gratitude towards many people who have been sort of crucial in my academic journey, in particular my mentors and endorsers, specifically Federico, Professor Narhari, Ariel, Yanis, and Professor Kanal. I would also like to thank my colleagues at the Indian Institute of Science. It has been a wonderful group there, especially the algorithms group. I would like to name Arindam, Rahul, and Anand. It's a delight. I feel lucky to be part of a group where I can not only share credit of my work, but share the joy of such achievements. And finally, I would not be standing here had it not been for amazing graduate students, amazing younger colleagues and collaborators. I think much of the credit here also goes to them. So yeah, thank you again.
Thank you. So again, congratulations to all the winners. I mean, you can choose the way you want to celebrate. I put certain icons over there. because this is the age of emojis and icons, so I figured that it wasn't complete until I put something like this. So hopefully next year we will have more and more awardees on the ACM side, and again, such illustrious award winners on the ACM India side as well. So with that, thank you very much. Congratulations again, and thanks to the people who contributed to it. Meenakshi?
Yeah, with the award ceremony sort of sandwiched between the talks and the lunch boxed between the award ceremony, we are back to Talks by Laureate, and it's my pleasure to invite Professor Jayant Haritsa from IISc, past president of ACM India, to please chair the talk.
Yeah, so good afternoon and welcome to this session where we will have the distinct pleasure of listening to a captivating lecture by Professor Yael Kalai, who is currently a senior principal researcher at the Microsoft Research Labs in Cambridge, Massachusetts, and also an adjunct faculty of computer science at MIT. Yael received an undergraduate degree in mathematics from the Hebrew University in Jerusalem and a master's degree in computer science from the Weizmann Institute near Tel Aviv. She then moved over to the US and received her PhD from MIT under the mentorship of the legendary Turing laureate Shafi Goldwasser. Yael is celebrated for her breakthrough results in the verifiable delegation of computation, especially doubly efficient interactive proofs, and for also laying the theoretical foundations for the Fiat-Shamir heuristic. And it is in recognition of these highly creative contributions that in 2022, Yael received, was the proud recipient of the highly coveted ACM Prize in Computing. And incidentally, that prize is sponsored by Infosys. So today, Yael has actually been with us for a week. She was at the Pingala Interactions in Computing in Mysore for the last weekend, and then she went to IIT Madras, then she came to Microsoft Research in Bangalore, as well as at IISc. We thank her for being so generous with her time, and we have thoroughly enjoyed having her here. So without further ado, on behalf of ACM India, I very warmly welcome Professor Yael Kalai and request her to deliver the lecture.
Can you hear me okay? Yes, okay. So, thank you so much for inviting me, for the amazing hospitality that I've been receiving in India in the last kind of more than a week now. I have to tell you, I've had the time of my life. I love this place, I love the culture, I love the food. I'm really enjoying myself. So with that, I'll give the last talk of my trip, and after that, I'm heading back home to my children. Okay, so I'm going to tell you, what I'm going to tell you today about is how to verify computations that are done on untrusted platforms.
So the way we do computation has changed dramatically in the last, I don't know, 20 years in a very, very fast rate. So we used to do computation on our own devices. For those who remember, may look like this. And the important point is all our computations were done locally on our own trusted devices. This has changed. Okay, so today, computations, no? Okay. Computations are done often on untrusted platforms. Often a lot of our computations are done on some cloud platforms. And this is really due to the amount of huge kind of computational burdens that are put forth by today's reality. So this is due to these public ledgers, for example. Now we have blockchain technologies where even verifying the correctness of a single transaction is a huge computational burden. Of course, this is becoming even more so with all these deep learning, the large language models, and very heavy machine learning algorithms that are here today. And so kind of verifying these computations that are done on kind of other platforms is really, really crucial. So here's the problem. So this new reality brings with it a lot of challenges. For example, the first challenge that we're concerned with is economical challenge. For example, how do we price these computational burdens? I'm not an economist. I am a cryptographer, though, so I'm really interested in privacy. If our data is put elsewhere, what about the privacy of our data? Machine learning models are trained on our data. We may be concerned about privacy. So actually, I'm very interested in this regime, and I've been working on it quite a lot, but this is not the topic of this talk. Actually, what I want to talk about today, and the challenge, is that of intent. Namely, when we outsource our computation, how do we know that the output we get is true, is the correct output? Okay, so when you ask a large language model a question, it gives you an answer. How do you know it's the correct answer? Okay? So let me give you kind of a specific kind of example of something I've been working on a lot, and that is the efficient verification of some program. So here's the question at hand. Say you have a program M. Okay, M is for Turing machine. But it's some program, a C++ program, Python, whatever you like. Think of it like as a short description of a program. And you have an input X. And you want to run this program on this input. But this program runs in a lot of time or requires a lot of space. And you don't have the resources to run this program. So you outsource, you give this program, you give the input to some platform, an untrusted platform, and tell the platform, you do the computation for me. And the platform does the computation and produces a Y, an output Y. How do you know that that's the correct output? So really what you want the platform to do is also give you a little proof that proves that indeed it ran the program M on input X, and Y is the output. So a little more formally, what we want from this clicker, maybe I can use this. Oh, it comes, just delay. Okay. Okay, so the first requirement we want is what we call completeness, which essentially means if the platform, or what we call the prover, does everything correctly, it should be able to produce such a succinct proof without too much overhead. Okay, so a bit more formally, what we say is, if indeed Y is the outcome, and let's say it takes time T to produce it, then one can generate a valid kind of succinct certificate or proof of Y in time, not much more than T, so there shouldn't be too much more overhead. And this is very important, the size and the time it takes to verify their certificate should be much, much smaller than T, since otherwise, what's the point? You'll do it on your own device. Okay, so the crucial point is verification. It should be very, very efficient. And of course, you want the prover not to have too much overhead, otherwise you won't be able to use this. Okay. So this is what we call completeness. How about soundness? So soundness just says that, intuitively what soundness says is that if, yeah, I know. Oh, I need to point here. Okay, got it. Okay, soundness should say that if Y is not the correct output, you should not be able to generate a certificate. Okay? Easy. That's the goal. Clear? Okay, let me tell you. Impossible. You cannot achieve this goal. Okay, so why am I why am I sitting here, in this honor and telling you about a task that you cannot achieve? So the reason is, if I had to define what cryptography is in one sentence, I would say that cryptography is the art of overcoming negative results. So when you work in cryptography, no matter what you try to do, you hit a wall. That's not possible. And kind of what cryptography really is about is kind of cleverly overcoming these barriers. So, and this is just one example of such a area where we hit a wall. And how do we overcome this wall? We relax the soundness guarantee that we ask for. In other words, instead of saying, look, it's impossible to generate valid certificates, namely, valid certificates just do not exist for wrong answers. Instead, what we say, that it should be practically impossible. What do I mean by practically impossible? What I mean is, maybe one can do it, but if an adversary manages to generate a false certificate, like a fake certificate of a false answer, it means that adversary can break my cryptographic assumption. Now note, this task seems like it has nothing to do with cryptography. It's not about hiding. Usually when people talk about cryptography, they think about hiding data, hiding, a secret message. I'm not hiding anything here. I just want correctness. That's all I want. Where did I sneak cryptography into this game? Okay, so again, what I'm saying is, I think, look, you may be able to cheat. I'm not saying cheating is completely impossible, but the only way you could cheat is by breaking some cryptographic assumption. Okay? Now, where does this cryptographic assumption comes into play? So first of all, this soundness guarantee is what we call computational soundness, because it really only talks about soundness against computationally bounded adversaries. Because if an adversary is all-powerful, he can always break our cryptographic assumptions. An example of a cryptographic assumption, for example, is that it's hard to factor large numbers. If you're all-powerful in exponential time, you can always break these assumptions. Okay? And the idea is, well, if you run in reasonable amount of time, let's say, time bounded by the next 50 years or whatever it is, you should not be able to break our assumption. So where is this cryptographic assumption? Where do we hide it? So we assume that the prover and the verifier have access to what we call a common reference stream, like some short string. You can think of it, sometimes it's just a random stream. Okay, and this, we call it CRS for short. The CRS string is needed both to compute the certificate and to verify the certificate. So as you'll see, just jumping ahead, in our actual protocol that I'm going to show you, this CRS is just a description of a hash function. Okay, because you may be confused now. Wait, where does the CRS come from? Who decides on it? What is it? So as an example, and that's what we'll see today, in the example of this scheme, it's just some off-the-shelf hash function. Okay? So this is the goal. Any questions? Okay. So this goal is what's called a succinct, because we want the certificate to be succinct, non-interactive, because it's not an interactive thing, it's just a certificate, argument. Argument is just a word a word for computationally sound proof. So we don't want to call the certificate a proof, because if you're all powerful, you can fake it. That's not what a proof is. So instead we call it an argument. And for short, we call it SNARG. I don't know if any of you heard this buzzword SNARG, but now you know what it is. So this is the goal of what I'm going to tell you about today. And here's the theorem. The theorem says that we can indeed construct such a snark for any computation. So you give me your program M, you give me an input X, I can give you a Y along with a succinct snark, okay, or a succinct certificate. That proves to you, when you see that, you know, okay, Y must be correct, or maybe I'm a supercomputer and broke the cryptographic assumption. Okay, so, and we know how to do this based on some standard cryptographic assumptions, which I don't want to, I just put it in gray, but I don't want to get into. But we can, for example, do it under post-quantum secure assumption. That's kind of what we're, as a community, we're focused on these days. Okay, so in the rest of the talk, what I want to focus on, is the journey. So this is something I've been working on for many, many years, actually starting from the end of my PhD at MIT, on and off in various works, of course. And what I want to, before I go into this journey that I found was a really, really fun journey, I just want to mention that I think the reason this journey was so amazing is due to my really fantastic collaborators. I was extremely lucky throughout my career so far to work with amazing, amazing people, my students, my postdocs, my colleagues, mentors. So all the works I'm going to talk about today are joined with, various co-authors. And really, I think that as much as I enjoy science, and I really, really do, I think like working with these people is the biggest joy of all. And in general, these collaborations are really make this journey kind of really, really special. Okay. So actually, the construction of snarks, or the main kind of foundations, started in the mid-'80s with the introduction of what's called zero-knowledge proofs. Now, zero-knowledge proofs is very different from what we want. It's something completely different. So what is a zero-knowledge proof? A zero-knowledge proof, the idea, is actually about hiding. This is a cryptographic idea, okay? So the idea is there, you want to give a proof that reveals no information beyond the fact that the statement you're proving is correct. That's what a zero-knowledge proof is. Okay? So in the mid-'80s, this notion was defined, a proof that reveals no information. That was the goal. And now they constructed it. They constructed a zero-knowledge proof. How do you construct a zero-knowledge proof? So actually, once they defined this notion, or in the process of defining this notion, the first thing that they realized, this is Goldwasser, Mikhaili, and Rakov. Goldwasser and Mikhaili are both Turing Award laureates. I should say, Shastri Goldwasser, my advisor, who won the Turing Award, won it after I was her student. Just saying. Okay, so after they defined this really, really beautiful notion, what they noticed is that actually it's impossible to construct zero-knowledge proofs. Okay, so again, beautiful idea, boom, a wall. Okay, so what do? Again, as I said, you have to overcome it. That's the creative part in cryptography. How do you overcome these negative results? And let me tell you why, intuitively, why is it impossible? What is a proof? Okay, a proof is like a bunch of, something, piece of paper, many pieces of paper, maybe 100 pieces of paper, that you verify kind of line by line. It's a bunch of logical deductions. That's what a proof is. So a proof, in some sense, always contains information. For example, you can sell a proof, so it's worth something. Okay, something that you can sell for money, it has some information in it. So that's in an intuitive level. But actually, you can formalize it and argue that any proof, like a class, what we call a classical proof, cannot be a zero-knowledge proof. Okay, this is again high level without giving any definitions. But actually, this talk is not about zero knowledge. I want to talk about snark. And the reason I'm mentioning this result is because in order to overcome the negative result, what they did is they defined a new way to come up with proofs. They defined a model of interactive proofs. Now, this model was defined for constructing zero-knowledge proofs. And indeed, they were able to convert any proof into a zero-knowledge proof using this model. However, what's really interesting. This model is interesting way beyond zero knowledge, and it's kind of the foundation of constructing smart good work. And it's really been instrumental in all of kind of proof theories, PCPs, and a bunch of kind of laid a lot of foundations in complexity theory as well. Okay, so what is an interactive proof? An interactive proof is an interactive process between a prover, which is by P, and a verifier P. And this proof is kind of an interactive process where, the prover sends a message, the verifier asks a question, prover sends a message, verifier asks a question, so on and so forth. So it's per verifier. That's a conversation with a specific verifier. Moreover, and importantly, the verifier is randomized. The verifier actually tosses coins. And this is critical because if the verifier was deterministic, so no, the verifier is weaker than the prover. The prover is the strong man who's kind of doing the work. If the verifier did not toss coins, then the prover could compute the verifier's next messages. So nothing about it is really interactive. So really the kind of the power of this proof system comes from the fact that the verifier tosses coins, the verifier's messages are randomized, and the prover can't predict them ahead of time. And the soundness guarantee is probabilistic. Namely, the guarantee is that a cheating prover cannot convince the verifier to accept a false statement except with some small probability. Now, first when you look at it, you may be like, okay, this is a problem because I don't want to accept a small probability of error. What is a proof? What if the small probability happens? So now I get a proof of a false statement? So don't worry, this is actually not a concern. And the reason is, even let's say if the probability of error is half, which is very large, if you repeat it k times and accept if and only if all of them are accepting, then you can reduce the error probability to 2 to the minus k. Okay, which is tiny. So I don't repeat it 500 times. The probability that you accept a false statement is 2 to the minus 500. It's smaller than the 1 over the number of molecules in the universe. Okay, so it's practically zero. Okay, so the probability of error for practical purposes is zero. Okay, so why am I telling you about these interactive proofs? And what is the relevance of interactive proofs? So beyond the fact that they played a very important role for constructing zero-knowledge proofs, for which Afi and Sylvia won the Turing Award, they also they were noted shortly after they were introduced. It was noticed that these proof systems are very, very powerful. Okay, so what do I mean by powerful? So here's an example. Consider a chess configuration, a chessboard with some configuration. Let's say I want to prove to you that the black player has a winning strategy. I don't know if it does, but let's say I want to prove to you that it has a winning strategy. How do I do that using a classical proof? Actually, really, I don't know how to do it efficiently at all. The only way I can think of giving you a classical proof is to say, well, no matter what the white player does, here's a move of the black player, such that no matter what move the white player does, here's a move to the black player, and so on. And then see the black player wins no matter what. But this is going to be a huge, exponential size tree. So the proof is exponential size, it's gigantic. It turns out that with an interactive proof, we can do this very, very succinctly. Now, why, intuitively, why is interaction helpful? Why is it easier to use interaction? So here's a very, very high-level intuitive reason why. Let's say I want to now tell you, look, I have a winning strategy. Give me your biggest grandmaster. Give me the best player on earth. I'll play them and I'll win. So let's play interactively. Me, you see I won. Now, okay, that doesn't mean really that the black player has a winning strategy. That means that the black player can win that specific grandmaster. But that's kind of the intuition. Okay? Actually, to make this precise, the interactive proof is much, much more complicated than what I just said. And somehow we run kind of over all the possible grandmaster at once in some very, very high-level intuitive way. And as a result, the prover becomes, in order to prove, the verifier is very succinct. The communication is small, the verifier is very efficient. But the runtime of the prover that needs to convince the verifier is gigantic. It's actually, in the original work, it's like even more than exponential. It's like 2 to the, anyway, huge. Okay, so there's a huge blow up in the prover runtime. Okay, so whereas the example I said, let me play against the grandmaster, that's no overhead. Really, I'll just play. But actually to do this, to convince you that I can win all the grandmaster or all the possible players, then essentially the computational burden on the prover becomes huge. So while this is a beautiful model, and a very, very strong result. This result, by the way, can be made much more general. We know kind of there's a characterization that all interactive, you can prove any computation in what's called P-space that takes polynomial space. You can prove in an interactive proof. This is just a statement, a result in complexity theory. So while this result is very powerful, it's only of theoretical interest because there is no way you can implement this. Okay, so in 2008, this was towards my end of my PhD with Shafi, my advisor, and a fellow student and a very close friend, Guy Rothblum. We wanted to construct an interactive proof where there's not too much overhead on the prover side. Yeah, the verifier is very, very efficient. That's a requirement. But we don't want the prover to run in exponential time. So instead we say, you know what? If the computation takes time t, the prover should not run in time much, much more than t. Okay, what do I mean? Well, if you're a theoretician, polynomial in t is good. If you're a practitioner, you want linear in t. You care about the constant as well. But that's kind of the idea. Okay, you want to minimize the overhead. And at the same time, you want the verifier to be very, very efficient. Okay, so here's the theorem that we proved. So we call such a interactive proof a doubly efficient interactive proof, since it's not only the verifier that's efficient, also the prover. Okay, of course, the level of efficiency you want from the prover and the level of efficiency you want for the verifier is not the same. The verifier should be much, much more efficient, but also the prover should be relatively efficient, should not run time much more than t. And what we proved is that there exists a doubly efficient interactive proof for all bounded space, for all bounded depth computations. Now, where the communication grows linearly with the depth. Okay, so let me parse this. So we construct this doubly efficient interactive proof for bounded depth computations. Let me say what bounded depth computations are. So let me think about a computation as a circuit. Okay, so we have our input, x1 up to xn, that's our input. And we have like, you think of the computation as just a bunch of kind of a circuit that has any, I don't know, it can be and or not gates, or addition, multiplication, mod 2, whatever your, any kind of complete set of gates that you want to consider. So you have this circuit. Think of it as layered circuit. The depth is the number of layers in the circuit. Now, we show a doubly efficient interactive proof for any such circuit, but the runtime of the verifier and the number of rounds that require grow with the depth. They grow linearly with the depth. So if the circuit is very, very deep, it's not very interesting, because the verifier will run in a long time. So really, this result is really interesting where the depth is small. For example, you can think of polylog depth. And then, the verifier is super efficient. That is an example. But even linear and n depth and time much more. So, can be n to the 10th, can be even n to the log n. As long as the time is much larger than the depth, this result is significant. Okay, so so by the way, this is interactive, and it's only for bounded depth. I promise no interaction in any computation. So I'm far from delivering what what I promised. But this is an important intermediate step towards getting our snow. Okay, so let me say a few words about how you come up with this double efficient interaction. And actually the idea, the high level idea is very, very simple. So let me tell you the high level idea. Suppose you're the prover, you're trying to prove to me that this circuit, that the output is 1. Now, I want to catch you if you're cheating. That's my goal. The goal of the verifier is to catch the prover if he's cheating. So how do I catch you? I'm going to tell you, you know what, give me the value of the 2 children. I'm going to check that the gate is satisfied. If the gate is not satisfied, I immediately reject you. So you better give me something that satisfies the gate. Now, if you cheated me, if 1 was incorrect, is not the value of that gate, of the output gate, then 1 of the children must be incorrect. So what am I going to do? I'm going to guess and hope for the best. So I'm saying, well, if you're cheating, 1 of them is incorrect, maybe the left one. Okay, then I tell you, you know what, go to the left child, give me the 2 children. If the left child was incorrect, not the correct value, then 1 of the 2 children is not the correct value. Unless the gate is not satisfied, in which case I immediately reject you. Okay, if 1 of them is not correct, I'm going to randomly guess which one. Maybe the right. And this is how I continue. I ask you for the 2 children, I choose 1 of them, I go down until I reach a leaf. A leaf is an input value. It's one of the input indices. Let's say I know x3. I know x. I, the verifier, know x. So I check, is it correct? If yes, I accept you, otherwise I reject. That's a very basic and intuitive, simple protocol. The only problem with this protocol is that it's pathetic. Why is it pathetic? Because every time, let's say you cheated, every time with probability half, I choose the wrong place. So in order to catch you at the end, I need to every time guess where your cheat was. So I'll catch you only with probability 1/2 to the death. So I'll catch you, you can cheat with probability 1 minus 1/2 to the death, almost with probability 1. So this is not a good protocol. However, this idea was actually very, like this basic idea is very instrumental. Why? The reason it's not a good protocol is because every time you go from a layer to the layer below, you lose a probability half of catching the prover. Half is too big. I don't want to lose. I want to say, if you cheated here, you must cheat here. Or with very, very high probability to cheat here. That's really what I want. And the way we get that is by essentially the high level idea is we encode. We tell the prover, encode each layer using an error correcting code. What does an error correcting code do for you? What error correcting code does for you is, assuming you encode it correctly, what it does is it ensures if somewhere in the layer you gave the wrong answer, almost everywhere in the encoding there will be a wrong answer. So if you're wrong in the layer above, with almost certainty I'll go to a place where you're wrong in the encoding of the layer below. So again, to enhance this probability, to get probability close to 1 that I continue to catch you, I move to the encoding. Okay, and again, the idea behind this error correcting code is if a single gate in a layer is incorrect, and the encoding, almost everything will be incorrect. Of course, this still is a big problem because now how do you do the reduction on the encoding? When we did it on the gates, it's simple. We just check the gate. How do you, and then coding, it's like, wait, it's not even clear how you do it. Things seem actually much more complicated. Sorry, the slides moved, things moved a little bit from my laptop to here, so things are a bit off. But essentially what we do, we have a much more elaborate kind of reduction protocol where we go from one layer to the other layer on the encoding. So we prove we go kind of from a value on the encoding of a layer to a value of the encoding of the layer below. And we argue that kind of if you are incorrect, you will continue to be incorrect with very high probability until you reach the bottom. Okay, and what this and the bottom, of course, you can verify on your own. And what this reduction protocol is, that's actually quite complicated, and that's where the beautiful math comes in. That involves kind of polynomials and finite fields and beautiful algebra. But that I won't have time to talk about today. Okay, so where are we? What did I kind of, in a very, very high level, what did I show you so far? I showed you an interactive proof. I promised non-interactive, but I delivered interactive. Only for bounded depth computations, where I promised all computations. And, by the way, with no cryptography. In the beginning, I told you there's cryptography, no cryptography. This is a real interactive, this has what we call statistical soundness. Namely, even if the prover is all powerful, it cannot cheat, except with very, very small probability. That again, we can push down to zero, or almost to zero. So I need to remove the red component to make it non-interactive in all computations. Okay, so this protocol is referred to as the GKR protocol in the literature, and I'll refer to that as such in the talk today. Okay, so unfortunately, during this talk, I'm not going to tell you too much about how to get around the bounded depth part. That's just requires kind of heavy cryptography. But essentially, what the very, very high level intuition, what we do, if your circuit is very deep, there's a way kind of to squash it using cryptography. So there comes a lot of kind of commitments and like digital commitments, and some kind of fancy cryptography comes into play when you want to squash the circuit to make it down to depth. So the idea is you start with a circuit. If it's small depth, I'm happy. If it's high depth, I squash it, and then run GKR on the squash circuit. Now, how I squash it, and actually it's quite technical. So let me skip that part, and let me actually take care of the interactive part. So let me show how I get rid of interaction. And the reason I want to focus on that is because I think the techniques there are much, much more interesting. Okay, so in order to reduce interaction, I'm using a property of the GKR protocol that actually a lot of our protocols in cryptography have this property. And this property is called public point. Public point means that the verifier in this protocol simply sends random bits. So the messages from the verifier are not complicated messages. It's just randomness. So if you remember the simple the toy GKR protocol I showed you where without verifying code, what does the verifier send? Every time with probability half left, with probability half right. Just a random bit. That's public point. Okay, where the verifier just sends a random bit or random set of bits each time, this is a public point protocol. And the GKR protocol, even on the encoding, remains a public point protocol. Okay, why am I focusing on this public point issue, on this specific property? Because we have actually a beautiful heuristic called the Fiat-Shamir heuristic for eliminating interaction from any public point protocol. Okay, so you give me any public point protocol, I can get rid of interaction from. So let me actually tell you how this is done, because it's so beautiful, it's simple, and it's widely used everywhere. Okay, it's one of the most heavily used kind of paradigms in cryptography. So let me demonstrate it for 3 messages. So suppose you have an interactive proof that consists of 3 messages. Prover sends alpha, verifier sends beta, prover sends gamma. How do you eliminate interaction? The idea is you tell the prover and verifier, agree on some hash function. So what is a hash function? Think of it like the idea behind the hash function is like a function that behaves randomly. Okay, Okay, that's the property we want a hash function. That's a good hash function. A good hash function is one that really behaves like a random function. Now we have a lot of on-the-shelf hash functions that are used. People use them all the time. Okay, so agree on one of these hash functions. For example, I know SHA-256. That's one of them. And now we tell the prover, you compute the beta of the verifier. So there's no verifier anymore. The beta of the verifier is going to be now simply a hash of the transcript so far. So essentially, instead of the verifier choosing beta, we'll let the hash function choose beta. Or in other words, instead of having the prover interact with the verifier, he'll interact with the hash function. Now, if the hash function is really, really random, what does it matter if you interact with the verifier or the prover? Both of them send you random bits. So interact with the hash function. That's the intuition behind why the feature-mirror paradigm should work. Say, look, if the hash function is really, really good, if it's really like random, then what does it matter if the verifier chooses it or the verifier chooses beta or the hash function chooses beta? That's it. So this is the paradigm. Okay? We eliminate the verifier. Verifier does not exist at all anymore, and it's the messages of the verifier are now replaced with the hash H of the transcript so far. That's it. Okay, and that's how we construct our scenario. So what is, remember, our scenario? A succinct, non-interactive argument. You just take the GKR protocol that's very interactive and apply the feature-mirror heuristic to it. And that's where the CRS, remember in the beginning of the CRS, think of it as a hash function? That's exactly the hash function. Okay, so the prover and verifier agree on the hash function, and now the prover on its own comes up with the entire GKR protocol. Every time he expects to get a message from the verifier, he essentially applies the hash to the transcript so far, and that defines the message. So that's it. That's how we get this. Okay? Great. So that begs the following question. Is this paradigm secure? Is this heuristic secure? Now let me tell you, you better hope that it's secure, because we're all using it all the time. Okay, any of you who has an iPhone, every time you're using your iPhone, the feature paradigm is in there, because all the Apple devices, their signature scheme relies on this feature heuristic. So we better hope that this heuristic is sound. Now, let me tell you, in practice, it is sound. So don't worry, it was never broken in practice. Okay, well, so I'm a theoretician, okay? So if it's used all over the place, people believe it's sound, there must be a proof, so we should be able to prove that it's sound under some, property of the hash function. So can we come up with a proof? I mean, probably not independent of the axioms, so we should be able to come up with a proof. So when I started thinking about this, I was actually, before I came to work with Shafi at MIT, I was a student in Zaytun Institute, and I was advised by Adi Shamir, who also wanted to enroll after I was a student. So I really wanted to prove this paradigm. I really, really wanted to impress him. But all of us had or have advisors, and you know how you really, really want to impress them? So I really wanted to impress Adi Shamir and to prove the security of this paradigm. And I spent a very long time trying to prove that it's secure. So much so that at some point I came home to my parents' house. My dad is an academic, he's a game theorist. And I remember I told him, I'm so frustrated, I'm spending all this time and I'm getting nowhere. And I remember he was telling me, well, maybe it's time to look for a counterexample. And I was so annoyed, I mean, I'm looking so hard. But I did. And we actually came up with a counterexample, showing that actually here's an example of a protocol, a public coin protocol. Contrived, I should say, contrived. We concocted this protocol. But we proved no matter which hash function you use for the fiat Shamir, the protocol becomes insecure. So, okay, what's the, what, so should you guys worry and stop using iPhones? No, this is a contrived example. And still, in practice, things work. So what this counterexample taught me, at least, is that if you want a proof of the Fiat-Tramier paradigm, you can't hope for a general proof that will work for all protocols, because such does not exist, because we do have a contrived counterexample. And let me tell you even more than that. Not too long ago, it was shown, actually, there's a first SNARG heuristic construction from the 90s, okay, that didn't have like a proof of security, of soundness under standard assumption. And recently, it uses the Fiat-Tramier paradigm. And it was broken. So the Fiat-Tramier paradigm kind of doesn't work for that. So why should it work for GKR? And the reason there was still hope, even though that was a bit scary, this result. The reason that there's still hope is because all the counterexamples, both our counterexample and the counterexample from 2019, were when the initial protocol, the interactive protocol, was only computationally sound. So the initial protocol had cryptography in it already. Now, GKR has statistical soundness. It's secure against any unbounded cheating proof. So then, of course, you ask, well, is the Fiat-Tramier secure when applied to statistically sound interactive protocols? Public coin, of course. Is it secure then? So a lot of sweat went into this question. And we worked a lot, many, many years on this question. And here's what we know. Actually, we believe the answer is yes, it is secure for any statistically sound interactive protocol. But we managed to prove it under very, very strong cryptographic assumptions. Ones that I'm not sure if I had to bet if they're true, the assumption is true or not. Not sure where I would go, so I don't believe the assumption really. But we showed that actually for a large class of interactive protocols, statistically sound protocols, that include the GKR, but include many others, actually you can prove that it's sound under standard cryptographic assumptions. So one example is the learning with air, LWE. I focused on that because it's post-quantum secure. That's kind of an assumption we like, but we know also under other standard cryptographic assumptions. Okay, so that's what I wanted to say about SNARGs. And then 5 minutes? It's 3:30. Okay, I'll just say a couple more words until Jen tells me kind of a hint. Okay, so let me just tell you kind of where we went with this, or where the community took it, not me, but the community. So, I'm a theoretician, as I said, I work in theory. This kind of line of work has been a really, really fun work as a large community, theoreticians and practitioners. So there's a lot of prototyping of these SNARG works. Some are GKR-based, the yellow are GKR-based, but there's a lot that use completely different techniques that have been implemented as well. This has been deployed by various, currently it's mainly being deployed by blockchain companies, but I feel like probably this will change. So this is kind of new. The most recent, or the most kind of well-known blockchain company that uses these terms are Ethereum. But there's many, many others as well. I didn't really do a deep search. So, I think in general, this kind of, this area was a big success story for us theoretical cryptographers. Now we're in the process of standardizing these things, and hopefully it'll be easier to adopt in the future. So I guess one thing I wanted to say is during this journey, when we worked about SNARGs, we found actually really, really interesting connections to completely unrelated areas in theoretical computer science. So just as an example, we use the GKR SNARG result to prove that it's hard to compute a Nash equilibrium. How does that come about? Turns out the Nash equilibrium is complete, or turns out we can use GPR to prove hardness. Okay. We found connections with complexity, with quantum complexity, which are really, really interesting. In particular, we found a really interesting connection between the concept of encryption and non-signaling, which is a concept that is in quantum mechanics. So completely different. Turns out these things are very, very similar. And again, this was kind of used in, this was not in GPR, but in another kind of work. So we found really, really interesting connection to other areas of theory and to cryptography as well. For example, the Fiat-Shamir paradigm, which was actually not introduced for proof systems. The Fiat-Shamir paradigm was introduced to construct digital signature schemes. Okay, so this is a very important kind of paradigm for signature schemes. So kind of, we found we learned a lot in the process. Okay, so do I have a couple minutes for, okay, I have. Okay, so let me just mention a few kind of problems we're working on now and kind of the things that I think are the most interesting open problems that I invite all of you to join me. It will really help me because, you know, there's some problems that I think I won't sleep well at night until someone solves them. So please help me out here. Okay, so the first one, which I feel like we're very close, we made a lot of progress, is the following. So far, I talked about proving correctness of a computation. But now, and succinctly, now here's another question. Suppose, forget about a computation. So a computation is a deterministic thing. You have a program, you have an input. Let me change it. Suppose you have a proof, like an NP witness, or a proof for some theorem, but it's very, very long. Can you use cryptography to shrink it, to make it short? You know, so for example, we all write papers. Some of our papers have very, very long and painful proofs to read. Can we use cryptography to just shrink it so that the committee, the people who need to assess these contributions can at least check for validity if the proofs are correct? Instead of, reading this entire, paper? Okay, so that's the question. We have heuristics that take long proofs and use cryptography to shrink them, but nothing under standard assumptions. So can we do it under, for example, the LWE, learning with air, which is our kind of planned, our favorite cryptographic assumption? So currently we don't know. We made a lot of progress. We know a large kind of class of proofs that we can shrink, but not all. So this is one thing that keeps me up at night. The other two, one of them has to do with quantum, and the other one has to do with LLM. So quantum, cryptographers are very worried about quantum computation, about quantum computers coming along. However, quantum computers can also be very beneficial to us because they're very powerful. We can use them. So now, suppose we have a quantum computer. We want to use this quantum computer. We want the quantum computer to do computations for us. How do we know that it's doing what it's supposed to? Let's say it's not our computer. We don't trust it. Someone else, there's one big quantum computer owned by, I don't know, Microsoft, Google, whatever, and that one we can pay money to, have that quantum computer do computations for us. How do we classical computers verify the correctness? Or can we verify the correctness of quantum computation classically? So this was actually done by a beautiful, fantastic breakthrough by Urmila Mahadev, who was a student at the time. But of course, there's a lot of ways we want to improve our protocol. First, it was still very, very long. We want to make it succinct. It's not succinct. Second, it has many rounds. We want to make it non-interactive. So there's still a lot of work there. And finally, the last thing is verifying indeed machine learning algorithms. And what the difference between verifying machine learning algorithms, or LLM, and what I talked about is that typically in machine learning algorithms, okay, it's done. But in machine learning algorithms, the problem is we don't know what the data is. Okay, so when in the LLM, we don't know the training data. So how do we verify something when we don't know the data? So this also requires kind of coming up with the correct question. Okay, so of course you can't do it. So maybe what if you have kind of you can access the distribution from which the data should have come from. Then can you verify? Can the LLM prove to you that the output is correct? So there's various kind of questions along these lines. I think kind of the robustness of LLMs is a huge issue for society that we need to deal with. I think cryptographers are equipped to deal with that, and I think that's one of the questions that we as a community should solve. Thank you very much. Yeah, feel free to ask me any question. It doesn't need to be super related to what I talked about. Anything of that purpose.
Hi, thank you. It was a very nice talk. I have one question regarding this fiat semi-transformation. So you mentioned to explain the fiat semi-transformation that alpha, beta, gamma, right? And the verifier sends that message beta. And now hash function or a random, it's a randomly generated. And the prover is generating it locally, right?
The prover is computing it.
Yeah, by hash of that alpha prior message.
Yes.
So if it is a not of a challenge, which is not going to give a correct proof for the prover, it is not beneficial for it, why not it replaces with a different alpha and generates H of alpha prime?
Great question. Okay, let me make, this is a very, very good question. So I guess the question was following, wait, peer-to-peer transfer paradigm can't work because here's an attack I can do as a prover, okay, and which I can never do with an actual verifier. I'll try alpha, I'll get a beta. Maybe I'm lucky and beta is the question I can answer. In which case I'll proceed. If I can't answer that question, I'll try again. I'll rewind, go find another alpha prime. And then go to the hash function. Hopefully now I can generate. I'll do it until I find a good beta, and then I'm done. So I should be able to cheat. So let me tell you, you're right. If you are all powerful, then you can cheat. However, in our protocol, beta is like, think of beta as like minimum, I don't know, 256 bits. It's big. It's K, like some security parameter, K. And if the statement is false, there's only very few betas for which you know the answer. It's a negligible fraction. So the probability that you'll get a good beta, that you know how to answer, good for the prover, bad for the verifier. But if the prover is lucky and gets a beta that it can answer, is negligible. And therefore, yes, indeed, that's why, yes, you can break it, but it will take a very, very long time. Great, great question.
Thank you.
No. Interesting. Okay, so the question, of course. I was about to repeat it, yes. So the question was, I started with like perfect completeness, perfect soundness for the definition of verification. I argued you can't have both, so I said, let's make the soundness computation. The question was, why the soundness? Maybe keep the soundness perfect or statistical, make the completeness. So, okay, I can lower the standard, so I can make the completeness not perfect, and sometimes in some schemes, they do that. But even if you have imperfect completeness, you hit the same wall. So you really, okay, here's the negative result. If you want statistical soundness, even if you elect completeness to half, or select completeness in any way that makes sense, you'll hit a wall. So you really have to, it's really the soundness that you have to relax. But that's a great question. Great, great question. Wow, you guys are good. Exactly. I can't keep the soundness by relaxing. in a meaningful way.
Great talk. You mentioned a couple of negative results, and while answering, you mentioned one more.
Yeah.
How are these negative results shown? I mean, and I assume they are unconditional.
Okay, no. Okay, great question. So, for example, the negative result for SNARB is actually a conditional negative result. Because, okay, so we don't really have negative results. So let me explain it better. The negative results often say, like for example, for SNARB, what we show, if you can construct such a little proof for any computation, then it will really violate our beliefs about complexity. We don't believe in complexity that any, let's say, time t computation is also in n time. So if you can do something proof, it's like a non-deterministic time much less than t. We don't believe that that's true in complexity theory. Now, we don't know how to prove any low bounds in complexity theory either. For all we know, p is equal to n t. We don't know. But we don't believe that's true. And therefore, we don't believe that kind of statistically secure or sound SNARBs exist. So that's a very, very good point. When I say it's impossible, I mean we believe it's impossible.
I mean, that's true for zero knowledge proofs don't exist also?
Okay, zero knowledge proofs don't exist is a bit more complex because it depends on your definition of zero knowledge. So if you want to define it, okay, they gave a definition that is very beautiful and general. Under their definition, it just doesn't exist. It's not. It's unconditionally just does not exist. But you can possibly define zero knowledge. For example, let me give you another definition. It's not zero knowledge. It's what we call witness indistinguishable. It just says, I'm going to take your proof. I'm going to convert it to another proof. The new proof, I'm not saying it's okay. Here's my zero knowledge guarantee. If you started with proof A or started with proof B, and you made it zero knowledge, it's not really zero knowledge, then the new proof looks the same whether you started with A or you started with B. So it's the most zero knowledge you could hope for, in other words. It's like the best possible zero knowledge. And then we know how to do non-interactive. So, it depends on your definition. Their definition is using a simulator. It's a very robust and easy to use definition that works in a composable setting. Their definition you cannot do one. But it depends on the definition.
And the unconditional ones are proved using some sort of a diagonalization kind of an argument? Or?
Okay, the witness in this, okay, if you want, okay, you can do non-interactive, but it's witness indistinguishable proof, and then you can do it under cryptographic assumptions. For the negative result of Shafi CPO and for the actual zero knowledge one, it's not actually diagonalization. It's if I gave you the definition, it kind of, you can see that it's impossible to achieve. It doesn't require actually diagonalization. Yeah, I didn't give you the definition, so I can't really answer the question. But no, it's not based on diagonalization. Thank you, guys. Thank you for the great questions. Oh, my tree. I already got a tree. That's my second tree.
You have added up to 14.
I felt very guilty taking a flight all the way from Boston. It's a lot of trees that I destroyed on the way. So thankfully, I feel,
So on behalf of the media, I'm delighted to.
Thank you. Thank you guys so much. Really, I'm delighted and honored. Thank you.
Yeah, it's now time for a coffee break, half an hour, and we're back for the last talk of the day.
Zoom Renegade. Did it splash off or something? Should I remove? And press the clicker. Okay. Volume from here. That's the video. Okay. And then you have to log into Zoom. Let's see the link. Yeah. I have those slides. Immediately after. Join the audio or that's not required. Yeah, it's clear. Share the first. Yes. Then this. No, I actually want to show some other screens. Then the entire screen. We can try. I think we are getting there. Is there an option to share the whole screen? Yeah, that is the other stuff. Okay. It's more. There is no. Yeah, there's the mouse. It has to be on this. I think I have enough power. Yeah, it should last.
Requesting everyone to please settle down. We're running a couple of minutes late. We'll begin soon. Yeah, good evening, everyone. As and when others are coming in, we'll start because we don't want to be very late for the last talk. Welcome to the last session, last talk of the day. May I invite Dr. Venkateshwaran to please chair the session.
Good afternoon, everyone. It's my privilege to invite Dr. Praveen Bhagwat to the stage. We've been hearing about 14 trees throughout the day today. Praveen Bhagwat is basically the founder and the brain behind the 14th Tree Foundation. So apart from his technology background and his entrepreneurial journey running a tech company, Praveen has recently, for the past few years, has taken time off to focus on looking at the sustainability of converting barren lands to creating sustainable forests by working with a variety of groups, including nature enthusiasts, the tribals, the villagers, and of course with the various landowners who have this barren land. Is working with all of them to convert those barren lands to sustainable forests. Prior to that, Praveen spent almost 15 years for running a company focused in the area of wireless networks. This company was called Airtight Networks, rechristened as Mojo, and then finally got acquired by Arista Networks in 2018. He was working with Arista and then took time off to focus on this new venture called 14 Trees. Praveen earned his BTech in computer science from IIT Kanpur, and then his master's and PhD from UMCP, University of Maryland, College Park. So let me welcome Praveen to the stage and take it off from here.
Can everyone hear me at the back? Yeah. So, I think about 3 months ago, someone called me up one day and said, we want you to give a talk at the ACM annual event where Bob is going to be the keynote speaker. And I say, no, you got something wrong here. I mean, you got ACM award winners and all the laureates coming and giving a talk. The last time I wrote a paper in ACM Novicom was 25 years ago, and at SIGCOM was 30 years ago. So I'm out of touch for 25 years, and there is nothing I can offer in the tech space to this community of people. I'm doing completely low-tech stuff lately, which obviously I can talk about. But after we sort of talked a little bit on the phone, I said, maybe I can weave a story where I can bring in some Ethernet and maybe some Wi-Fi and also squeeze in some ACM connection into this whole thing. And maybe that will make it a little bit contextual for the people in this room. So it's a stretch, but I'll try it nonetheless. So, and there's also a reason I started with this picture. And why I'm using this picture to start the talk will become clear somewhere halfway down in the presentation. By the way, there is no text in the presentation at all. It's all pictures. So make sure that you have a clear view of the screen because all the story is actually in the pictures. So I remember 1990 is the year when I started grad school at the University of Maryland. And in our networking group, we had these big workstations and cables running all over the place. And we used to work late at night. And you should think, someday these cables have to go away. Won't it be cool if we replace it by wireless? And I knew Bob already was thinking about it 30 years ago. It's just that the silicon was not ready. And I think 90s was the time when it was about to get ready in that form. And as the luck would have it, I landed up a job in 1995 at IBM Watson Research, exactly in the group which was building a 900 megahertz frequency hopping wireless LAN. So that's how my journey with Ethernet, wireless Ethernet actually started. And that's the picture I pulled out from the archive. US Robotics had built a device called Palm Pilot at that time, and IBM had done OEM deal with US Robotics, and they had rebranded as an IBM device. It had an RS-232 interface. And my project was to take the bits out of the RS-232, somehow package it up in 900 megahertz frequency hopper channel, and then send it out. And finally, this is the form factor we could manage. So that wireless adapter was 4 times bigger and heavier than the Palm Pilot, but people were kind of laughing at it when we were going around the corridor saying, hey, I sent a character P. So I think you had experienced that 30 years ago. We had the same joy in 1996, sending some characters across this RS-232 link. So that's how my kind of a journey started. And a few years down the road, I saw a lot of my colleagues leave IBM, start their companies. So I also got that itch that, maybe I ought to be doing the same thing. So I quit, started a company in wireless security, 2003, called Airtight Networks. And the insight behind the company was that Ethernet is secure because the wires are confined within the walls. But the moment you put the signal over wireless, an adversary can directly see what's in there. So not only can eavesdrop, can also inject packets in there, can also modify packets in there. So the whole security model of Ethernet breaks down the moment you kind of send a signal over wireless. And hence, a new attack surface started emerging that people could do denial of service attacks over Wi-Fi. Aside from the encryption which was broken, even if you had correct encryption, you could do replay attacks, you could do denial of service attacks. So a whole new demand kind of got created in the market, and the company I started, Airtight Networks, it was building an intrusion prevention technology using which you could secure Wi-Fi networks. And the insight was very simple, that if you have a bad guy in the air, Ethernet is a shared medium. Can you somehow shut that bad guy down? And it turns out that you can play tricks with the MAC protocol. And by playing those tricks at the MAC layer, you can cause a uncooperating guy to not have access to a channel at all. And that is exactly the technology that we created, patented it, built a wireless intrusion prevention product around it. And that's how my sort of entrepreneurial journey in the Wi-Fi security space started. Around 2009 is a year when there were a lot of hacks happened. The TJ Maxx retail store got hacked, and suddenly PCI compliance became a big deal, and people were looking for a cloud-managed cheap solutions for wireless security. That's when we pivoted and created a cloud-managed solution for these distributed sensors. And then around 2016, we entered the mainstream Wi-Fi market and renamed ourselves as Mojo Networks. Brought in some elements of AI, automated troubleshooting, smarts into the system. And finally, we got acquired by Arista in the year 2018. So now, Arista, as some of you know, is the leading provider of data center networking. In fact, every day, the data that you're consuming on your phone or your laptop is very likely it is coming through some Arista switch somewhere in the world. And so the wired, wireless, unified solution that Arista sells, the entire technology has actually come in from Airtight Mojo, which is now got embedded into the product. So that's how kind of I got into this space. Now, while this whole entrepreneurial journey was unfolding, I was living a kind of a split life. The headquarters was in Mountain View and the engineering was in Pune. So I was traveling a lot between the two time zones. A lot meaning maybe sometime 8, 9 or 10 times a year. So every 5 weeks, I used to be on the plane, go meet customers, come back, run the engineering. And one thing is, I realized that sometime when you're alone in the plane, that's the real quality time. Sometimes get to really think, reflect your role in the world, what you are doing, ask questions, and so on. So I got a lot of that time because of the travel I was doing. And naturally, many questions popped up in my mind. And one of the questions that actually popped up in my mind was, I have been a very nature lover since my college days. I do a lot of backpacking, trekking. I've been probably about 45 national parks in the US, camped there, done trekking. So you develop a lot of appreciation for nature. And those of you who live in or been to Silicon Valley, to drive on the highway 280, it's a beautiful stretch, beautiful scenery. And if you drive from Pune to Mumbai, that scenery is very similar to Highway 280 in terms of the kind of terrain and the mountains. But something that bothered me, that whenever I used to go from Pune to Mumbai, that highway is beautiful during monsoon, during rains, there are waterfalls, greenery, but there are times of the year I notice that those hills are on fire. So first I thought maybe it's just an accident. So I kind of ignored it. But I saw that pattern repeat every year around March, April time frame. The hills are on fire, and you'll see it more clearly if you're driving late at night. So typically when the flight from US lands in Mumbai, it lands at midnight, so you take a taxi, drive home, and at night when you're driving on that highway, you see all the hills are on fire. So I saw that scene over and over again in the backdrop of this wireless networking company I was running. And this particular picture, I remember I took it in the year 2016 when I was going for a sort of an off-site meeting in Lonavala. So I got down off my car, took the pictures, and luckily I had it in my archive. So these sites actually bothered, why as humans we are deliberately burning things down when we should be protecting and conserving. So in the slide picture I showed, so this was another question that I used to think a lot. Sorry. Then I remember once I was reading an Economist magazine in the flight, and this article was on global warming. It had numbers like before 1800 there was 600 gigatons of CO2 in the atmosphere, now it's 850. And after I read the article, I still couldn't relate to these numbers. See, if you work in networking, we understand what kilobit means, what megabit means, what gigabit means. But when it gets into the weights, I don't have that same level of intuition that I have for bandwidth. So for example, is this a number so big that I should lose my sleep over it? Or what is it that I do? How does it relate to these numbers? I mean, there's no connection. And then I remember and this is an incident from my first year in IIT. I remember that while we were doing the physics course, there's a very famous textbook by Richard Feynman. And while reading the textbook, there's one place where, and Feynman was a great teacher. I mean, he had a way to explain things. So I still distinctly remember there was one place where he asked the question to students, do you know how small an atom is? And atom is like 10 raised to the minus 10 angstrom. But he said, look, can you feel how small that is? And he gave a perfect analogy that you hold an apple in your hand. And now think about the earth. So compare the size of the earth with the size of the apple. That's how small the atom is relative to this apple. So that example, I remember when I read in the book, it hit me that if somebody has to come up with analogies, I mean, this is how analogies need to be created. And still, 40 years after reading that line, I still distinctly remember that analogy. And I was looking at these numbers. They are not able to inspire me to any action at all. I don't know whether they're big or small. So this was another thing which was on the back of my mind while I was taking these long flights. Now, I am an experimental researcher, so I like to tinker things. So I decided to get into this space, to start tinkering. So this is the piece of land I bought in year 2013. It was a completely barren patch of land. And started doing my experiments, what will it take to rejuvenate it? Can we regrow this without burning the land down? There was no water here to begin with. And after tinkering and experimentation over many weekends, I show you another picture. This picture is taken exactly in the same position of camera where the previous picture was taken. And this transformation has happened at that site in 9 years. Without bringing any water from outside, without bringing any soil from outside, without bringing any fertilizer from outside, using only the local resources available. So it was kind of a aha moment. Oh, looks like it is possible to kind of rebuild things from ground up. So after sort of having some success at doing it once, I started sort of trekking in that area and started understanding, what is happening here. So found out that about 50, 60 years ago, it was a thickly forested region. But if you look at the picture today, this is how it looks on Google Earth. It's completely all clean shaven. All the trees are gone. And the land has been converted from a forest into a grazing land. And it is burnt every month, every year in the month of March and April. So thousands of hectares are burnt. And this cycle repeats every year. So for the last 50, 60 years, this cycle has been going on. As a result, the land has become completely barren. It can't absorb water anymore. Water tables have dropped. And this is a story that is repeating sort of at a large scale in many, many parts of the world. So the idea sort of I'm trying is, starting from a land like this and without bringing any water from outside. Because the moment you lay pipelines, you spend a lot of fossil fuel, electricity to pump water back. And the thing is, there is enough rainfall, so why can't you collect the rainfall wherever it is falling? So without bringing pipeline, we are identifying strategic spots where we can store water. And here are some pictures of the type of ponds we have dug in that area to hold rainwater when it rains. Obviously, all the time you're not successful. Many ponds are not able to hold water. So the water percolates underground. So you play this game at a large statistical level, and we are getting about 50% success rate. About 50% of the holes are able to hold water, 50% become percolation ponds, but you need both. But whatever water you're able to store, you use it very, very carefully throughout the year to make sure that the trees that are planted can survive. So you only plant as many trees as the water capacity you have created. You don't do anything kind of beyond that. Now, the next question is, what kind of vegetation you bring back? And here, rather than trying anything fancy or foreign species, we have taken advice from some of the ecologists and botanists who have studied flora of that region. And they have given us a list of species which originally belong to that region. So we have brought seeds from jungles and grown saplings, and those are the trees we are planting. And these trees are not being planted with any return on investment expectation at all. These are trees which feed wildlife, the trees which feed insects, butterflies, and birds. So you essentially, your aim is to bring biodiversity back. And we are seeing some of that happen. That as you bring the right species, herbs, shrubs, revival starts happening. In fact, some of the ponds I've shown you pictures of, I can now see there's a fish in it. And it kind of puzzles me, where did the fish come from? But it came magically, I don't know how, but maybe the birds, something gets attached to their legs and it comes. So the cycle of life sort of starts operating and things start happening. Now, because these species are of the type which the cattle would love to eat, unless you protect each sapling, it can't survive. It won't survive. So every sapling that we plant, we put some kind of a bamboo tree guard to protect the sapling for about 3 years till it becomes big enough that it can survive on its own. And because we have created this demand for new tree guards, a mini industry of tree guard creation has spawned around our region. So there are many tribals now just busy making tree guards and supplying it to us. So we kind of stimulated that demand in the local economy. So since, we all have done tech companies, we understand what it means to scale. While this is a little toy experiment that's unfolding, obviously it is being done with the view that we want to figure out a replicable model to do it at a larger scale. And and I'm trying to do it as systematically as possible, that every tree has a number, every tree has a URL, we record every activity, when the watering is being done, how the growth, everything, whatever systematic measures that you can imagine. So it's in some sense a large-scale live laboratory where these measurements are being taken. And hopefully this data will become useful to somebody someday to do some systematic analysis. So finding the land, bringing water, planting the right saplings, protecting them. Few years down the road, I realized this was actually the easy part of the project. The real harder part of the project was doing it in presence of humans around you. Because there are too many stakeholders. There are local tribals, there are local villagers, there are sarpanch, there are local politicians who have their political base there. And since you're dealing with large amounts of land, everybody gets suspicious. What are you thinking? What do you have a plan to build like a large resort here or a game reserve? Where is the money coming from? Why am I not getting my piece of the action? I mean, all these kind of human questions come in their mind, and keeping everyone satisfied and aligned to the focus is actually a non-trivial thing. And what I realized that, in this whole picture, if you get humans out of the picture, land will rejuvenate itself in 100 years. The real challenge is, in presence of humans, how do you achieve this? So the complexity of the problem has shifted from the technicalities of biology and ecology. It is basically doing human management. And since I ran a company earlier, I was the president of the housing society, I had some experience dealing with people. So I said, this is an interesting, complicated problem. And the one thing I realized that when you are running an organization, you have some degree of authority and autonomy and control over the people who report to you. But when you're working in a structure like this, you have absolutely no authority and control. The only way you can manage or lead people is through influence. And that's a very slow and a process that you can't guarantee any outcome. So I'll show you some little examples of kinds of socio-psychological experiments we have done to align people. So the first example is, this is a picture of our attendance board. As I said, the project currently employs over 100 tribals. And every day, this board changes. Whoever comes to work, their picture is put up on the board. So what I realized after some time, that people actually started liking the fact that their pictures were on the board. Because before that, there was no, people were treating them as like pure laborers. There was no like identity that they had themselves. And there's a sense of pride that, my picture is there, that created that emotional connect with the project. So we started with a very small team of 5 people. And slowly, this picture started spreading in their community. And now the numbers started swelling. And during COVID time, suddenly I had about 100 people show up one day saying, look, we are looking for jobs, because all the industry around it was shut down. And that is the time when I realized that it was time to kind of take a sabbatical and put full-time focus into it. Otherwise, it was becoming very difficult to manage this affair. So suddenly the labor pool became available overnight because of the COVID shutdown. The second interesting experiment I tried is, there's a road leading up to the project site. So I got the names of all the villagers from the local sarpanch and made nameplates. And one fine morning, put up plates on every tree, indicating that this tree belonged to that particular villager. So when people woke up that morning, they saw there's a tree in their name. There's kind of a very unexpected development in the community, and people are kind of puzzled and amused. Suddenly, what has happened? And it's not that they would start watering their tree just because the tree is in their name. But we noticed that something very interesting is happening. I had hired a contractor to water these trees every week. And the contractor is a local boy. So villagers started chasing him. Hey, I didn't see you at work last week. Go and water the trees. So my entire overhead of monitoring completely went away. And the locals took charge. And I'm glad to report that we have more than 95% survival on this roadside plantation. While normally on roadside plantation survival, it is very, very poor. Just because the people's emotions got involved in making sure that the project succeeds and survives. Now, once I sort of understood that connecting names with trees was a formula that seemed to be working, whenever any visitor who came to the project site, we started this new sort of a ritual or a procedure that every visitor fills. See, this is running low on battery. Just give me 1 sec. Let me connect the power cord right there. Otherwise, we lose the. So whenever visitors come to the site, we have this little ritual that everyone fills up a slip, put their name, we put the tree number on that slip, we take the picture of the person with the slip. So in some sense, we have given MAC addresses to every tree. Because every tree has to have a unique identifier. We say, why not give an identifier to each tree and then you just do a name mapping. So now we have just like in the DNS, you have a IP address to MAC address mapping. Similarly, we are doing a name to directory mapping. So, for example, the cards or the gift cards you have received, that mapping is captured in that card. So, we've got this basic primitive now, that the name and map to the MAC address of the tree. So, with this primitive, now what is interesting is that you can play many interesting games. So, I'm a graduate of IIT Kanpur, and Institute had invited me to give a talk in year 2020, February. I went to give a talk. After the end of the talk, I came to know that about 750 professors have retired since the founding of the institute. So I said, give me the list. And I came back and created a faculty group and shared this news with the director, and the director was very happy. Yeah, this is fantastic. At least, there's a tree in the name of every professor. And then something even fantastic happened. That year 2020 was the year when the institute, IIT Kanpur, was celebrating its Diamond Jubilee. And the director had the grand plan to go all over the world, raise funds, meet with all the alumni, and that entire trip was cancelled because of the lockdown. So I called up the director and I said, well, there are about 40,000 graduates spread across the world. I have enough land. I'm going to plant a tree in the name of every graduate. And this will be your Diamond Jubilee celebration because you can't get out of the institute anyway. So he agreed. He said, it's a fantastic idea. So because of COVID, this project got blessed by the institute. And we are sort of creating the Diamond Jubilee Grove. And the director himself came to inaugurate that event. Now slowly the word is spreading. And since Pune is a city which is a turf of IIT Bombay. So my IIT Bombay alumni came and contacted, what's going on? We also want to create a grove. So IIT Bombay Grove has been created. And slowly, the word is kind of spreading from one person to another. And I'm hoping that there are about 10,000 alumni groups in the country. So if that wildfire can start, everywhere the trees will start popping up, where there'll be names associated with all the trees. So once you've got this basic primitive of mapping names to the trees, you can play many variations of it. So alumni grove, faculty grove is one way to kind of slice and dice the problem. When my daughter graduated from high school, there were 60 of her batchmates, and she said, well, let's do a grove in name of all of my batchmates. So I said, okay, let's do a Gurukul graduation grove. So 60 trees standing on a farmer's land, that's become a capture of their times together. So you now have anniversary groves, you have birthday groves, you have basically name any excuse that you want to remember, and we have a mechanism to create that grove at the project site. And one of the grove which is actually is receiving a lot of traction is Memorial Grove. People actually want to pay homage to their loved ones, come and plant a tree, have something live in memory of their loved ones. And here's an interesting story, not exactly to the people in this image, but a related story which I want to narrate. And I'll show you kind of how one idea leads to another. So there is a good friend of mine, his name was Swagato Basumale, and he died about 2.5 years ago. So when he died, we have our batch WhatsApp group, and there were a lot of outpouring of emotions on that group, people remembering, such a great days we had together in the hostel, what a fantastic guy he was. Somebody wrote an article, somebody posted pictures, one person wrote a poem. And what I noticed that there was a lot of that activity was there for about 10 days. And then as sort of memories fade, and WhatsApp is a media where, once some message goes out of 2 scrolls, it has served its lifetime. It doesn't have any meaning anymore. So I saved all of that content that was shared on the WhatsApp group on my local hard drive. And after that, even I forgot about it. Now, a year later, around the same day, the message again became alive. It was 1 year, and how great Swagato was, and what a tragedy. So at that time, I posted a message in my batch group saying, look, I'm planting a memorial grove in his name, and I would like you to spare half a day in your life, come visit Pune, and plant a tree with your own hands. And since then, about 25 of my batchmates have actually come. Somebody lives in, US, somebody lives in London, somebody lives in Delhi, Bangalore, all over, but about 25 have come. And the remaining have said, look, we will come someday. So I have, commitments. Now, when we make the dashboards for those trees, I started linking the content which they had posted a year ago about that person. So the content which was dead has suddenly become alive. Because now when you scan the tree, the piece of article the person had written, the piece of poem that the person had written has become alive again. And I'm also imagining that as you walk through that forest and as you scan different barcodes, those memories will come alive on your device. So the insight is that I'm seeing forests as a memory sequestration spaces. It's not about carbon sequestration, because memories are far more valuable to humans than carbon sequestration. And the value of memories is also much higher than the value of the carbon. So the attempts to finance a lot of reforestation projects by selling carbons are not going anywhere, because the price of the carbon is rock bottom and is just not enough to do it. While this project is growing and still doesn't have a viable financial model, but every day we are getting more and more people come and join. So an interesting kind of insight that came from this. Then there is another experiment we did. Arista hosted a mobility field day event 2 years ago, and question came, what gift to give to each delegate? I said, well, plant a tree and say that this tree will make their home Wi-Fi carbon neutral. So now they can use 24/7 Wi-Fi access point without any guilt at all. And people loved it. They said, wow, this is a beautiful gift. So we are kind of coming up with different ways to slice and dice the problem and position. So that actually brings me to the ACM Grow. I think thanks to Hemant, he visited our site 2 years ago. And this is a location at the project site where the work was already going on. You see how barren the land is. And the pond digging was happening, and in the rainy season, we were able to collect some water. And when Hemant came, and actually the first picture that I showed is exactly the picture where the ACM Grove is actually coming up. And you can see a few trees there, one by one, that they're kind of coming up. So when Hemant came 26th March 2022, he planted a tree in the name of Al Aho. And I think that's how the tradition of planting a tree in the name of Turing Award winner started, with Al being the first person. And then the next year, I think Shafi was the keynote speaker at the, yes. Yes, yes. And Abhiram. So, yes. So Shekhar actually stayed at the base camp that day. He didn't come to do all the trek, but he was there that day. Yes. And then, sorry. But I think the year when Al's tree was planted, we did not have the design of the gift card ready. The gift card was designed a year later, and this is the gift card that was gifted to Shafi. And she was the keynote speaker at the last year's ACM annual event. And this year, 28th Jan, again the ACM India Council members came and they said, we want to personally come and plant trees. So all the trees that were gifted in the event today were actually planted by the people in this group. So there are real sort of connections involved. And I hope this tradition will continue for years to come. And these are the cards which capture the pointers to those trees, and a variety of trees have been planted. Now, an interesting story is the illustrations for this cards have been done by some artists who are just volunteering their time for 14 trees. So none of them is and they visited the site they like. So my daughter runs this program. She has a long list of species she wants to get illustrated. In some sense, we are limited by the species which have been illustrated. We are kind of giving preference to those types. But once all illustrations are done, we will be able to plant more varieties. But it has kind of become a fun project now. People who have a creative bent of mind, how do I make this gift more engaging to the group? So this journey of transforming the barren land into green has sort of started. And we are trying to make this journey kind of exciting, fulfilling, enjoyable. Because one thing I have learned, you don't want people to act out of moral obligations. Because people act out of moral obligations once. But if they enjoy something, they like something, they want to do it over and over again. So we want to turn this whole climate action into a fun, enjoyable activity for all people involved. And hopefully, sort of bit by bit, we are kind of getting there. So these are the real pictures of the barren land that I showed you earlier. Today, if you go to the site, this is what it has turned into, and more land is slowly turning into green as more and more trees are getting planted. So we have now, so interesting, we started a project with about 4 acres of land. Now the site has grown to about 200 acres. And then from the neighboring villages, we have access to additional 1,200 acres of land. So the land supply is increasing. And we are getting land from the farmers, we are getting land from the local villagers, we're getting land which we are also acquiring to add to our preserve. So vision is we'll create a kind of a man-made national forests someday. And the message about this activity is spreading through word of mouth primarily. There's really no outbound marketing at all. And within about 25-kilometer radius, we are now spread out over more than 100 sites where the work has now happening. And one day, actually, I sat on the Google Earth and measured. So that little green blob that you see is a 200-acre land where the active work is going on. Then little green little rectangle on the left side is another site that we have. And there's about 10 square mile of area which is sitting barren. And the good news is that the owners of these sites are automatically coming to us. Hey, take our land, add it to your pool. So that pull has kind of started. So I'm hoping that in few years, I'll be able to show a picture where, we have successfully transformed this area. So as I said, technically it is not difficult. It is getting humans to agree, yes, do it on my land. That is the harder part. Because everyone's got different ideas about what they want to do their land, etc. And this kind of a project actually is very relevant, timely, especially in this decade, when the whole United Nations wants to promote such activities all over the world. So the timing is good. And we are structuring this whole project as an open source activity. So while we've got the on-ground machinery very much running, there's an immense amount of back-end work that is needed to scale this up. Because imagine a database which has identifiers of all trees, you want to run different kinds of queries on it, you want to create gift card, you want to automate, you have new kind of imagery coming in. I mean, there's an immense amount of software development work that is needed at the back. And slowly, I'm kind of in the process of creating that community which will kind of pool in their efforts to help grow this activity. Now, at this point, I will take one pause and tell you that this project, no matter how many pictures and images I show you, nothing beats the experience of a real site visit. But I also realize it is not possible for everyone to come on site and have that experience. So I've sort of challenged many creative minds, how do I tell the story? And also we are living in a world where you need to have an elevator pitch for everything that you're working on. And my struggle has been, how do I create an elevator pitch for something that is going on? It takes about, half an hour, 40 minutes to give a talk. Still, I can't relay even 10% of what's actually going on. So I'll actually give you a teaser of one collaboration I have recently done with a creative mind to convey the story in 4 images. So forget about the last 40 minutes I've been speaking. I'll now try to summarize that in 4 images. And the way the narration goes like this. This is the picture of the real site taken a couple of years ago. Now my daughter, she likes to do paint, so she took that picture and created a painting, oil painting of the landscape. And then we took that painting and we converted that, we took that painting and converted that into a collage. Now, what is this collage? If I zoom in, this collage has thousands of pictures of barren land from my archives. Over the last 10 years, I have been doing a lot of trek in the area. And over COVID, when I was kind of jobless, I sat one day to compile all images together and put all the barren land pictures at one place and added them together to turn this, and you can see here the land is being burned, land is being mined, land is being kind of abused, being dug out. So the sentiment we want to convey is there's a massive amount of barren land sitting out there. Now the next collage is the economic activity we are generating on that barren land. So this is again a collage. And the story of this collage is, I had created a transaction recording system. But every day we are doing 10, 15 transactions to fund the project. For every transaction, I have asked the people on the ground to upload a picture capturing what the transaction is about. So over the last 4 years, now we have thousands of pictures of meaningless objects. So if I zoom in, each image represents some transaction in the local economy. You know, I bought some vegetables, I hired this guy, I rented a tractor, I bought these pipes, maybe, you know, brought this drum full of material. I mean, some, you know, minuscule transactions, but we now have thousands and thousands of these images. And this collage tries to show that all of it is actually adding up to fuel the local economy, generating jobs and fueling. And that's why people like it. You know, since the arrival of the project, many people have got livelihoods and they want the project to grow because their business will grow. So barren land, large amount of sitting there, job creation in the local economy. Now the third image, we protect each sapling with a tree guard. And there are thousands of these tree guards lined up in that area. And this kind of attracts attention. People are kind of curious, what is this? So this collage is made using thousands of pictures of locals who have walked into the site out of curiosity to figure out what's going on. So we have a process. As soon as somebody walks into the site, we take their picture, we write their name, and we say, we are going to plant a tree in your name. So we are building a database of real people, real names, real images. And every day, more and more people are walking in and are getting sort of connected. So our community outreach is expanding every day. And that is what this image essentially tries to, the story this image tries to tell. So to repeat, the barren land, job creation, community engagement. And finally, this is the collage. This is again a real picture taken at the site. This collage is again made using thousands of images clicked on the real project site. So these images are of birds, butterflies, flowers, herbs, shrubs. None of this existed when the project started. So the barren land has got transformed into this. And in the process, we have created jobs, we have created community engagement. So this is sort of a completely different way of telling the story. And we are now working on sort of more iterations and variations of this. So with this background, I kind of switch the gear again to the original talk where I was. That this is our view of the ACM grow. I mean, we just started planting trees there, so it will take many years before trees will grow and this will become like a green zone. But vision is that it will be cool to build a database of all trees on globe. So that number will be in trillions. And the reason people are coming to 14 trees because they have seen the site, they know the tree is real, it's there. So that trust is there that, you know, the card is not fake, it is real. When you scale it up, how do you maintain that trust? That's a very non-trivial computer science problem, actually. And obviously, everyone cannot come and experience that space themselves. Hence, there is a need to create a virtual walk through such zones and deliver that experience online through some AR/VR. And finally, we want to have stories, memories attached with every MAC address that's behind each tree. And I think this is very much the forte of ACM. And I love an opportunity where maybe Google, Microsoft, or IBM sponsors a summer internship or a master's thesis to work at 14 trees. We can keep not just one, but many students busy to build this platform in time. So with that, I think we are at the top of the hour. I think you already explained what the name 14 trees comes from. So I'll end it with the two aspirational sentences. One is obviously we've kept the name 14 trees because we want everybody on earth to take it seriously. And finally, given this particular forum, this would be a real kicker. If we can really get a tree for every MAC address active on Earth, because then we are talking about 7, 8, 10 billions, or maybe who knows, another 20 billions. So with that, I think I'll stop. Any questions? Happy to take them.
Hello.
Yeah, actually, the terrain is kind of.
Can you just repeat the question?
Yeah, the question was, have you looked at the methods where you do something from the plane? Like, people are talking about some techniques by which you can do seed dropping, or you sort of drill holes and plant it. I have not tried those methods yet, and two reasons. We are not yet ready to automate this stuff. I think the first order problem right now is to just create jobs in the area. So if we bring in automation too quickly in the project, it will create social unrest. So first we want to make sure everybody is busy and they're not able to handle the scale that we're talking about. At that time you bring in automation. And the second reason is the plantation is a one-day activity. The maintenance is a 3-year activity. And maintenance requires water. So water is the most critical problem there. So a lot of our effort goes into creation of water bodies, digging up ponds, and then distributing water from those holes to the trees. And again, we are doing a lot of it manually right now, but slowly we will bring in automation as the scale of the project grows.
There was a question there. Yeah. No question?
Yes.
You have a question?
Any other question?
This is a fascinating talk, and I was wondering, this is in Pune. How do we get it to go elsewhere?
So we are looking for branch heads in each geography. That's the only way it will scale. So idea is we are creating a playbook and hoping that, so for example, some folks from Bangalore have approached me, some folks from Chennai have approached me, and they would like to create something like this. So that's how it will scale. But this project will take easily 50, 100 years to roll out.
Yeah. Thanks for very fascinating talk. So I was just wondering about what was the main incentive for the landowners to really offer, I mean, what they were getting?
Actually, good question. So I'm focusing on land, which is completely non-productive today. So land where a little bit of agriculture is possible, I'm staying away from it, because then you have to do something which is better than that. So land which is totally useless, people think nothing can happen here, that's the land we are focusing on. And people are seeing that if this guy can green it, the water can come, then maybe it will become valuable to them. So the incentive is something is better than zero.
I think one question she has already asked. So, when you say valuable to them, so what does it actually mean? Like they can sell it, or they can, that's one thing. Second question, so do you have this geolocation of these trees also in this, or it's only you upload the pictures or you upload the information?
So if you go to the dashboard, there is a Google Earth interface where our aim is to show the exact pinpoint where the tree is located, but that piece of code is not fully ready yet. In fact, I'm looking for an intern who can work. We have that info, we're just not able to display it adequately yet. But we have the information for each tree, yes. Yeah. Yeah, so, see, you have to take that risk. I mean, there are going to be certain percent of people who will benefit from our work and will try to monetize that benefit in some other ways, which is not consistent with how we want to see it. But at a scale, you have to take that risk. Otherwise, you'll never start. So I'm assuming 30% of our effort will go waste. Or more, I don't know. We'll find out. Yes. Yeah, so it started with I sort of putting the capital on the table, but now the project is being run through crowdfunding. In fact, there's one more image. I see if I can show that to you. That will answer your question. Yeah, so this is another collage. So we have a counter at the project site. Anyway, so we have a counter at the project site, and as the trees get planted, the counter goes up. This is again a collage made of using the faces of people who come, sponsor, and plant trees. So more and more people are coming and sponsoring. And ACM, so we have many organizations like ACM. Interestingly, IEEE has now woken up. They came to know ACM is doing something. So then they want the plot adjacent to ACM for them. That's fine. But another idea just came to me. Maybe I can start auctioning. If you want a tree next to Bob's, you got to pay more. Or some, you know.
I think we'll just take one last question.
I'm looking for people who can write code. Absolutely. I don't need help in digging pits because I've got people who can do it much better. I need people who can write code.
All right, in the interest of time, I think we are exactly on time, right? Meenakshi, are you good? Okay. First, let me take this opportunity to thank Praveen for a wonderful talk and inspiring all of us to plant 14 trees to compensate for our life on this earth. Thank you, Praveen. And as a token of appreciation from ACM, there is an organization called 14 Trees that you may be aware of. So we thought we would just ask you to plant a tree that you have already planted. So this is just an information about the tree that you have planted in your name. And you can track the progress using the QR code, or you can personally visit your tree every week that you're there and
Let me
monitor
admit,
the progress.
this is the first time anybody is gifting the tree. You want to
Yeah, give us a couple of minutes at max to switch the machines now. The earlier switch was justified because we probably saved some MAC addresses interacting and saved a few more trees from being planted. So now we're at the end of the day. It's time to say thank you. It's time to say goodbye. And it's also time to know where are we going next year. So I invite Professor Supratik Chakraborty, the Vice President of ACM India, to announce the next year's venue and for the vote of thanks.
Okay, thanks, Meenakshi. Yeah, so all good things have to eventually come to an end. So we are at the end of this year's annual event, ACM India annual event, ARCS and the ACM W India event. So before I give the vote of thanks, here is the announcement about next year's annual event. So this will be held on 1st of March 2025. Okay. So the venue will be PSG College of Technology at Coimbatore. This is in the state of Tamil Nadu in southern India. And just like this year, there will be co-located events, which is the ARCS Symposium and the ACM India Women's Summit in Computing. And for the ARCS symposium for next year, the PC chairs are Professor Shibashish Guha from TIFR in Mumbai and Dr. Niharika Sachdeva from Naukri.com. And on 27th and 28th February, we'll have these two events, and on 1st of March, we will have the annual event. And now, with that announcement for next year's event, let me give the formal vote of thanks for this year's event. Everybody who made this year's event so successful over the last 3 days. So first and foremost, our distinguished speakers, Bob McCafe, Yael Kalai, Sriram Krishnamurthy and Praveen Bhagwat, thank you so much for taking time out of your busy schedules and enlightening us with your talks. The awardees, Nutan Limaye for the outstanding contributions to computing by a woman, Sudeep Mishra for the outstanding contribution to computing education, Siddharth Burman for the Early Career Research Award, Pranjal Datta for the ACM India Doctoral Dissertation Award, Jogendranath Kundu, who joined us online, the honorable mention for the ACM India Doctoral Dissertation Award. The various ACM India chapter awardees, UPES, ACMW Student Chapter Dehradun, MUJ, ACM SIGBED Student Chapter Jaipur, PCC OE, ACM Student Chapter Pune, AISSMS, IOIT ACM Student Chapter Pune, KRE ACM Student Chapter Madurai, VIT Chennai ACMW Student Chapter Vellore. Thank you for all the representatives from these chapters to come here and accept your awards. Of course, colleagues from ACM HQ, Yanis Ionidis, President, Vicky Hansen, CEO, Pat Ryan, COO, and Ruth Lennon, ACMW Chair. Thank you very much for coming here on this occasion and sharing your experiences and insights and giving us advice. A big thanks to the organizing institute, which is the National Institute of Science and Science Education and Research, NICER, particularly NICER Director, Dr. Hitendra Kumar Ghosh, who was here this morning. The organizing chairs for this 3-day event that we had, Aritra Banik. Aritra, are you here somewhere? Okay. So, Shubhankar Mishra. Shubhankar? Yeah, okay. Big round of hand for them, please. Devi Prashad Dogra. Devi Prashad, are you here? Not here. Manas Jyoti Kashyap. So they are the ones who are, leading the entire team responsible for all the logistics here. All the students from NICER who actually worked behind the scenes to, make everything smooth for us. So I'll just read out their names. If any of you are here, please stand up. I mean, you all deserve a hand from us. Rucha Balachandra Joshi. Are you here? Not sure. They're probably still taking care of logistics. Jyotirmoy Shivottam, Jyotish Kumar, J, Shriman Keshri, Adil Shah, Anubhav Vishwakarma, Aritra Mukhopadhyay, Prashman Ghosh, Pinky Pradhan, Bhaskar Goel. None of them are here? Okay. Sarthak Gupta, Parveen, Aravind Panda, Ritvik Raghav, Ayush Anand, Narasimhan Kovalai, Ram Sundar Tanikela, Shubhra Jyotsna Dash, Anuj Chaure, Sai Krishna Jupali, and Sushant Kumar. All the logistics were really taken care of by this team of very dedicated students. Some of them have come in. Yeah, thank you very much for all the organization. Then we had the audio-visual team, which was led by Prasanna Kumar Muduli and his team for all the audio-visual arrangements. Thanks to the sponsors of the various awards, in particular Persistent Foundation, Google, Tata Consultancy Services, Microsoft Research India, and Walmart Global Tech. Thanks also to the event sponsors, Persistent, TCS Research, Google, Carillon Global Solutions, Flipkart, Dell Technologies, and IBM. Thanks to Microsoft and Plaksha University for sponsoring the dinner last 2 days. If you did not know, they were sponsored by Microsoft and Plaksha University. Thanks to ACM India Women Chair Rudvi Shah and her team for the ACMW India event, and to all the ACMW India event speakers as well. Thanks for sparing your time to come and present your talks here. For the ARCS Symposium, once again, our thanks to all the speakers, the steering committee members, area chairs. There were 18 area chairs who were involved in selecting the papers from academia and industry. And a special thanks to the program chairs, Arpita Patra from Indian Institute of Science. She had to leave a bit earlier today. And Karthik Ramachandra from Microsoft. Thank you very much. All the chairs and jury members of the 4 awards. Rajiv Alur led the jury for the doctoral dissertation award. Meenakshi Balakrishnan, I think he's here somewhere. Yeah. So he led the jury for the OCCE award, Outstanding Contributions to Computing Education. Sandhya Dwarkadas, I think she's also here. Thank you for leading the jury for Outstanding Contributions to Computing by a Woman. And Sunita Saravagi, she couldn't be present here, for leading the jury for the Early Career Researcher Award. And Vineet Kapoor, Vineet, you're here. Yeah. Thank you for leading the jury for the chapter awards. And of course, behind all of this, throughout the course of the last 1 year, there are a lot of individuals from ACM India who have put in a lot of hard work to make sure everything happens smoothly. In particular, Chandrasekhar Shastrabuddhe Shekhar, thank you very much. Avijat Vichare, Avijat, are you here? He's probably still arranging our return logistics now. Hemant Pandey, of course. Hemant, thank you. Meenakshi D'Souza, who emceed the entire event, and Venkatesh Raman, thank you. It's also, an appropriate occasion to mention that Shriram's, Bob's, and Yael's visits were sponsored by a special grant called the Pullur Distinguished Computing Visitor Program Grant. So this is an ambitious program that was launched a year back in collaboration with the Indian Institute of Science and ACM India through a very generous donation by Ms. Nirmala Govindan in memory of her husband J. Pullur, who founded Pramati Technologies. And this grant supports visits of distinguished computer scientists of the highest global stature to India to give talks at one of ACM India's top events, and also to interact with students and researchers at various academic institutions and research organizations in India. So our sincere thanks to the Pullur grant for supporting the travel of our distinguished speakers. So with that, we come to the end of this program. And of course, there are many other individuals who have put in their own part in making the events over the last 3 days a grand success. So thanks to all of them. Thank you very much. See you next year.
some people tomorrow, personal basis, those who are staying here tonight, okay, thankfully, uh, if they would like to visit Konark temple or the Jagannath temple, uh, meet outside. I think we can, it's on personal basis, so we'll probably do a carpool, and Manas and local people but can probably book cars for us. Okay, so let's meet outside.
Like those who are staying in Niger or around, there is dinner tonight here. Same place, yes.